Welcome to DataEngBytes. I couldn't be more excited to have you with us all today. My name's Peter Hansen, one of the organizers. Really excited for today's lineup. Without further ado, let's just get started. So first up, let's take you through the lineup for today. Maxime Beauchamont, CEO and founder of Preset. He'll be revisiting his famous blog post, The Rise and Downfall of the Data Engineer. Up next, we've got Stephen Bailey's call to arms to data engineers that privacy is our problem. After that, Xin Lang of Eliza will be taking us on a journey of a machine learning model from experiment to production. Mercedes Speroni then walks us through chain speed inference to computer vision pipelines. Two great machine learning engineering talks to round out the morning session. So from there, we'll break for lunch for half an hour. And after our lunch break, we will have the startup panel with James Weekly of Omnata, Ingrid Enzola of Shipit, Vishal Razal of Lumi Finance, and finally, Jess Flanagan of Descartes Technologies. Four fantastic panelists, joined by Simon Aubrey, Principal Data Engineer at ThoughtWorks. Once we've gotten through that panel, then we'll have three fantastic talks to round out the afternoon. Dean Nguyen taking us through Carter's approach to building great data products. Hamid Soki shows us how to build reliable data pipelines with shiftless testing. And then Chris Benson of Versa will give us a beginner's guide to Azure MLOps. I just wanted to also take the opportunity to thank our amazing sponsors, without whom this conference wouldn't have been able to be put on, certainly not to the quality that it has been, as well as, having the ability to offer a completely free conference experience to all of our attendees. So our sponsors are Snowflake, Fivetran, Databricks, Microsoft Azure, Amazon Web Services, Imply, Versa, DBT Labs, ThoughtWorks, HighTouch, Microsoft Reactor, Yao Conferences, and Cloud Shuttle. Thank you so much to all of our sponsors. We really appreciate both all of your efforts in supporting your local data engineering community here in Australia, New Zealand, and beyond, but also the contribution that you're making to data engineers throughout the region. So thank you very much. I also wanted to take this opportunity to do a huge shout out to our organizers and committee members of DataEngBytes. Our awesome committee is made up of Nitish Matthew of Afterpay, Ingrid Enzola of Shipit, Rowan DePelia of Atlassian, and Jess Flanagan of Descartes Technologies. We then have our organizers, Francisco Liwa, Aditya Najala, Claudia Silva Cabrera, Rafael Mello, Noel Hansens, Helen Anderson, Leo Hoare, Simon Aubrey, and Kelly Hodder. Thank you so much for all of the amazing efforts that you've put in to making this conference what it is. Now you might be wondering, how do I get the most out of DataEngBytes? How do I engage with my fellow attendees? How do I really get involved? So the answer to that question is that on our YouTube channel, on the live stream, in the comments section, you can ask questions there, and those questions will go to our speakers and panelists in real time, and the top questions will be brought up on screen and asked to our speakers and panelists. So that's a great way to engage. Let us know where you're dialing in from. We're always fascinated to see, the different parts of Australia and New Zealand and beyond, even globally, where people are joining us from. So we're really keen to hear from you and for you to say hello. For longer format questions or longer format discussions, join us on our Slack group. There's the hallway track and the introductions channel. Perhaps you're looking to hire data engineers and you might want to post a job ad in our jobs channel. So there's all sorts of areas on our on our Slack group, there's an Ask the Questions channel as well. So feel free to reach out, say hi. We're always keen to hear from data engineers of all walks of life. Now, whilst making the most of your conference experience, it's really important to remember our community member expectations. The DataEngBytes conference is dedicated to providing a harassment-free community for everyone, regardless of sex, gender, identity or expression, sexual orientation, disability, physical appearance, age, body size, race, nationality, or religious beliefs. We do not tolerate harassment of community members in any form. Participants violating these rules may be sanctioned or expelled from the community at the discretion of the organisers. Harassment includes offensive verbal or written comments related to sex, gender identity or expression, sexual orientation, disability, physical appearance, age, body size, race, nationality, or religious beliefs. Deliberate intimidation, threats, stalking, following, harassing, photography or recording, sustained disruption of talks or other events, inappropriate physical contact, unwelcome sexual attention, sexual language, imagery is not appropriate for any DataEng Conf event or communication channel. Community members are not to use DataEngBytes conference or communications channel in order to proposition any other member. Community members asked to stop any harassing behaviour are expected to comply immediately. Sponsors and presenters are also subject to the anti-harassment policy. If a community member engages in harassing behaviour, the organisers may take any action they deem appropriate, including warning the offender or expulsion from the community. If you are being harassed, please contact your organiser immediately. If you notice that someone else is being harassed, please intercede or contact an organiser immediately. If you have any other concerns, please contact an organiser. And so now, given that this live stream is taking place on Australian soil, we'd like to do a welcome to country. So I acknowledge the traditional custodians of the various lands on which we work today and the Aboriginal and Torres Strait Islander people participating in this conference. I pay my respects to elders past, present and emerging, and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of New South Wales. Wow, with all of those messages and announcements out of the way, I can't wait to get started into our first talk of the day.
Okay, let's start that all over again. No one could hear me. We've got audio now. It's the way we start all of these things, Zoom calls and everything. It's just, hey, mate, your audio is not working. Check your mic, whatever, pretty much. Max, Maxime or Max, which is the best one?
It's always easier to go with Max, so everyone can pronounce Max. So I just roll with that.
Yeah, let's go with that. So you're pretty much the forefather of data engineering. You know, like you've built some of the most amazing tooling that's in widespread use across data engineering, especially with Airflow, and now and you've got Superset as well, and Preset, the company behind Superset, now has gone public with its cloud launch and stuff like that. Is there anything else that you've got up your sleeve that you're secretly working on, or is it or are these two it?
Yeah, no, so I think that's pretty much. I have tons of ideas though that I'd love to share with people too. So it'd be maybe interesting topic after the talk to talk about like, hey, what are some tools that would be exciting to build nowadays in open source. But for now, I'm really focused on the startup and on Apache Superset as a real contender and really solid solution in data visualization exploration space, and really still like really passionate about open source and getting open source to really win in this space and in the data space in general.
Yeah, awesome. Sounds incredible, and we're super excited to have you here. You're going to be touching on revisiting your blog post, The Rise and Downfall of the Data Engineer. I think that's going to be really insightful and a great way to sort of really get us into the zone of DataEngBytes. So I think without further ado, I might just leave you to it. At the end of your talk, we'll be back to ask you a few questions that have come through from the live stream. But without further ado, take it away, Max.
Awesome. Yeah, so I'm going to take it from here. I've got a lot to say. So this is a new talk. So really often I recycle my talks in different ways. But this is brand new, fresh off the press. I thought that the conference was tomorrow because as it turns out, it is tomorrow already in Australia. So I was looking at the dates on the website. I've got until Tuesday. So I put together these slides over the past few hours and the weekend. So really fresh stuff. So really looking at the opportunity to check point on trends around touching data teams, touching the data engineer, touching organizations that are data driven. So I'm going to get started in just a second. But before then, just like a quick intro. So I think I got a fairly good intro already. So I'm going to go quickly through this, but I've been my entire career, so it's probably 20 years or so by now. It's been really focused on working with data and building data tools in different contexts. So been doing that for quite a while, and then since 2014, I've had a chance to work in the open, so working on open source. So 2014, when I joined Airbnb, I started working right away on Apache Airflow, or what became Apache Airflow. And we got some really good traction internally and externally very quickly. It turns out a lot of people needed something like Airflow at the time. And soon after, so it was the following summer, so less than a year after, I started working on Apache Superset, as I mentioned earlier. So Apache Superset is in the data exploration visualization. It's very much a business intelligence solution for modern data teams to explore, put together dashboard, explore their data, put together dashboards, share them. There's also a SQL IDE in there. So I encourage people to check out Apache Superset if you haven't, or if you haven't in a while, because the project and the product itself moving extremely fast now. So we've accelerated just the pace at which the product is growing and getting awesome. So encourage people to take a look if you haven't in a while. And then more recently, so a few years back, to a little bit more than 2 years ago, I started a company called Preset. So we're at preset.io, and we are very much like offering Superset as a service with a freemium offering. So that means you can try Superset for free, up to 5 people, and you can get started and check it out and see if it works for you. So that was the commercial bit here, and I'm going to get right into the keynote. I wanted to thank the organizers too. So it takes a lot to organize a conference. I know it because I've been involved in the organization of some of these. So thanks to the sponsors and to the organizers. It takes a lot to make this kind of event possible. So what am I going to be talking about today? So I don't know how many people in this audience have came across the 2 blog posts that are referenced in here, but about like 4 or 5 years ago, I wrote The Rise of the Data Engineer, and the idea was really to go and formalize the role, this emerging role at the time, and talk about like what is a data engineer, and what do they do, what do they not do, who do they work with, this sort of thing. So and then soon after, I wrote about some of the challenges around the role and some of the things that made it really hard to be a data engineer at that time. So some of the challenges and opportunities, that came with those challenges that existed at the time. So more recently, I thought like it'd be a good time to checkpoint and to talk about how this has evolved. So my plan was to go and rehash some of this stuff and to go like point by point and be like, okay, look at what has changed and how it has changed. But the talk that I prepared today derived a little bit from that. And I think I'm going to be much more interested today in talking about just emerging trends and not be anchored on these posts. But it is very much a checkpoint. So I'm going to be looking at trends around the data engineer. So trends in data teams, trends in data organizations. I'm going to try to talk about how these trends affect the data engineer role today. So that should be fairly interesting if you're a practitioner, if you're a data professional, if you care about data in any shape or form, you'll be able to look at, to listen and see how much you can relate. Wanted to say too that the goal here is to go pretty wide and shallow. So I'm not looking to go into a lot of depth in any of these trends. And I'm also working on a blog post that's going to be probably highlighting a lot of supporting evidence for the trends that I'm claiming. Keep in mind that this is very subjective in some way to my experience, right? So I'm sitting here in the middle of Silicon Valley, and my experience is very related to my vantage point. Actually, out of my window behind me here, I can see the Oracle buildings, just to provide context as to like where I sit. So I'm in the middle of Silicon Valley. I'm also in the middle of the open source communities and the modern data stack type of efforts. So that, provides some context as to what I'm observing may or may not relate to you in different ways because of my vantage point. Without further ado, so I'm going to start jumping into these trends and talking about them. So the idea here is I'm going to cover about like 14 or 15 trends and just talk about what these trends are and what they mean to data engineers. So one thing that has changed a lot over the past 4 or 5 years since I wrote these blog posts is that data infrastructure existed as a service at the time, but we've seen the rise of the pay-as-you-go model with things that scale to infinity in the form of hosted SaaS, right? So that means that the accessibility of the tooling and the variety of the tooling and the cost effectiveness of the tooling as all of this has been very, very transformative. From the data warehouse offerings themselves, right, with things like Snowflake and BigQuery and Athena, and all of the data warehouse offerings around like just getting tools that work where you can get started in minutes. You pay as you go. If you have little data, it costs almost nothing to run these services. And you can get started in minutes and get like a world-class service. So in the rise of the data engineer, I was trying to create a distinction between the role of the data engineer with in regards to the data infrastructure engineer. And I think what we're seeing now is that the data infrastructure engineer is likely to work at Google Cloud, or is likely to work in a place like Confluent, Databricks, Preset, right? And these people who provide a service to the entire world. So that means that companies like Airbnb, or at least like companies that will become the Airbnb and the Lyft and the Facebook of the future, are likely to have less of a data infrastructure team in that role to go towards vendors and cloud service provider, which is a great thing because we get much more economies of scale in that way, right? It's more efficient for a small group of people to run Superset for the whole world at Preset than having an engineer or two run such service in every company in the world. So we've seen also like just more variety in the tooling that is more catered to different personas and different workflows to support different workflows. So, and all these services are increasingly kind of pay as you go, try for free, which has been great for data teams. And for everyone really. So accessibility it goes directly with this idea, right? So that means that maybe smaller companies it was hard for smaller companies to have a data team or to be good with data because of the tooling was either prohibitively expensive or just not accessible. And now more is just easier for any team to be a data team, which is a really important topic to me. That's actually our mission at Preset, is to enable every team to become a data team. And, certainly in the information age, it's important that everyone can have access to great data tools and great data infrastructure. The next trend I'm going to talk about is the rise of data integration services. So data integration is actually a term that I've used over the past 20 years, right? So it's not a new thing in any way, but the shape and form it has taken has completely changed over that period of time. So we used to have like more box software that would be really hard to integrate. And now what we've seen over the past like decade or a little bit longer than a decade is a move towards SaaS in general, right? So nowadays, the average startup runs more than 100 SaaS services. And this is super great because anyone can have access to very useful tools, right? Whether it's for payroll or HR or your recruiting and applicant tracking systems, your CRM tool. So everyone has access to really great tools. That created an issue in a sense that the data would be very siloed, right? So if you use Salesforce, you use HubSpot, you use Lever or whatever tool you pick to manage your business, you would create all of these silos that would be kind of isolated with the data stuck in these different places. So about 4 or 5 years ago, the way that you would deal with this is you would start to essentially like write a bunch of script, or either you'd give up, if you're a small enough company, or it's hard for you to or if there's not enough ROI for you to do this, but you would start writing script to go and scrape essentially or bring data using API calls in tools like Salesforce. That was really prohibitive and brittle and kind of awful work for data engineers, right? So if you think about a data engineer, you're a data engineer 5 years ago, and your goal is to integrate with HubSpot and synchronize your customer list and your deal list and your contact list. This is not super fun work. It's very brittle. You have to update your API. So that used to be very painful and brittle and error prone and just not that interesting of work. And nowadays we see the emergence of tools like Segment, Fivetran. On the open source front, there's Meltano and Airbyte. I think there's Stitch powering or Singer, Stitch, other tools that are just make it easier for people to integrate their data. So that's a great advancement. It's something definitely to embrace. The fact that it's easier now to collect data and bring it to your data warehouse, or even to integrate point to point in many cases. We've also seen the reverse ETL space become more common and the tooling starting to emerge. So I think we're fairly early in that area, but that's High Touch, Grouper. I'm sure there's other solutions. Those are just the ones that I know. So it's not like vendor preference or anything like that. It's more like I know these tools and I know people are using them. So the idea with reverse ETL is like bringing data from the warehouse and into your marketing type tools or CRM or anything really, right? The idea is to take data from the data warehouse and bring it back to SaaS services. So a lot of advancements there. And I mean, what does that mean for the data engineer? Is like you don't have to deal with that directly. You can focus on the transform layer. You can focus on infrastructure and on frameworks, as opposed to writing these like point-to-point integrations or these like integration to scrape data to bring it to the data warehouse. Next topic. So ELT over ETL. So I think people talk about this like it's kind of a new trend. I wanted to mention it here. I don't think it's new. To me, ELT has been strong, and maybe I need to define what that is. I'm pretty sure most people in the crowd will have an idea what this is about, but maybe an easy way to explain this is whether the transformations are done inside the data warehouse using typically SQL. So that would be in the case of ELT, right? You extract your data from your source systems, or you use your Fivetran, Meltano, AirByte to bring your data from your source systems raw to your data warehouse, and then you do your transformation inside the data warehouse using typically SQL. ETL is more in the traditional ways. We add specialized tools that would enable you to do this. Things like SQL Server integration services, Informatica, things like Ab Initio and IBM Data Integrator. So there's all these tools that were doing computation in a specific tool. So it would extract your data, transform it in that ETL tool, and then send it back to the database. As it turns out, databases are really good at processing tons of distributed data in the absolute best way. So it does make a lot of sense to reuse the resources that you use for querying or for your analytical workload on your database, to reuse these tools and this infrastructure to process your transformations as well. So I think we're seeing more and more that the data warehouse is the place where transformations are getting done. Of course, there are things like ML workloads and things that require computation that databases might not be able to do as easily. So I'd call it more advanced custom transformations. My belief in that area is that we're going to see more ways to write, UDF, so user-defined functions, or ways to bring the compute that you want to bring to your Snowflake, your BigQuery, your Athena, right? So to bring your computation to the distributed engine that is the data warehouse. Moving on, next one is, I call it mountains of templated SQL and YAML. And this one, first I'm going to talk about the trend and talk a little bit about what that means. But clearly, I think, just to start with a little bit of history, when I started writing Airflow in 2014, I knew that a lot of what it's going to be used for was going to be to schedule templated SQL. So I baked Jinja, which is a templating engine, deep into the Airflow engine so that we could do that very well. So at the time, it was clearly, a large percentage of ETL, call it 50 to 90%, was authored as SQL, right? So I would say the majority of transformation expressed as SQL. For a moment there, we thought that data frames-based APIs and things like Spark or different ways to, things like Apache Beam would become a more mainstream and more expressive way to write data pipelines. And I think what we've seen recently with just the way that Airflow is being used and the rise of tooling like dbt, that people are doubling down on using templated SQL and templated YAML as a way to express their transformation. There's a lot of really good reasons for that. SQL is declarative. It's lingua franca of data. It's easy to learn. It is widely known, widely adopted. It is very much a standard language, and it seems like people relate to its expressiveness. What does that say about, is that good, is that bad? For me, it's hard to get excited about a bunch of templated SQL. It's also hard for me to think about an alternative that I want to use, right? So for our data warehouse, for our own use cases at Preset, we selected templated SQL and YAML as well, just because it's common, it's easy, works well. It's a great way to talk to the database. So it's an obvious choice. And it has implication in the sense that if you want to build a lot of reusable components and frameworks, you end up with these like macros, so Jinja macros, and these constructs that are dealing with assembling strings together to try to write SQL dynamically. And sometimes that's not a very expressive and great way to build things. So a lot of implications there. I'm planning on writing a blog post on this specific topic of like what does that mean for our industry, and really like maybe what would be preferable and what are the challenges that comes with another decade, presumably, of a lot of transformation written as mountains of templated SQL and YAML. The next topic that I have is the rise of the analytics engineer, which I think is really interesting and very related to the accessibility of the previous slide. So what we've seen recently, and it's hard to qualify that movement, outside of my vantage point, but is more so analysts, so people who are sitting and that are more vertically aligned. And by that, I mean they are sitting part of their product teams often, right? So they sit with people with whom they share goals, as opposed to sitting with people with whom they share skills. And that means that the analysts, first affiliation is to the product team. And analysts I've learned to, essentially, they've learned SQL, and they've learned Git, and they've learned YAML, and now they can write data pipelines, which is a great thing, right? Every time we see more data literacy and more people being able to build more things, it's a great thing. I think this has a lot of implications for the data engineers. I'm gonna try to explain that. To me, it is a core function of data engineering too, to author a transformation, whether it be as SQL or not as SQL. And the skill requires are knowing SQL, being good at data modeling, and of course, caring about all the things that data engineers care about, which are things like SLAs and performance and data quality, and all of these things. So what is there to say else on this topic? There's probably the something around what does that mean for a data engineer, right? So now that you have hordes of analysts, or a handful of analysts maybe in your team, that are also checking in code and writing SQL, I think there's a role. Presumably, maybe the data engineer is closer to infrastructure, closer to data modeling best practices, closer to writing sustainable code on the long run, maybe has more experience doing so. So I think there's a role of education and support of how do we support this new role as data engineer? How do we support analysts in writing great SQL, reviewing code, following the naming conventions, and then maybe writing data quality assertions and all of this. I think there's a little bit of a DevOps type role. The DevOps equivalent, or call it data ops, role becomes more prominent for the data engineer. And there's also a role of education and code review and defining excellence and best practices, and things like SQL linting maybe might be a topic, right? How do we make sure that the SQL looks and consistent? So lots of implications there. Is it eroding away from the data engineer? I don't think so. I think it's still core to the role of the data engineer to write data transformation. It's just like now there's a new friend on the block, right, helping out and also like trying to get work done. So there's a question of how we team up and work together. Data literacy and specialization on the rise. So a lot to say here. We are, as I mentioned earlier, in the information age, and data has certainly been a focus, and it will stay a focus for the decades ahead. So that means that more and more people are becoming rapidly more sophisticated with data. And that's because those skills are very valuable to be a modern information worker, right? So this trend is not about to stop. It's taking different shapes and form. And one of those is analysts learning to speak SQL and learning Git, right? Like that's like, if you want to be a great analyst, you're probably going to have to be great at creating data structures and managing them and maintaining them. And you have to be great at data modeling. So that's very true and will stay true. What are some other examples of that? So I think I'm going to make that point in a future trend that's very related to this one, which is the next one. Maybe I'll pivot to the next slide, and I might be kind of in between these two slides and go a little bit back and forth. But maybe one more point on this one is that increasingly being sophisticated with data and being able to partake in the analytics process, which I will define here, it is a really important skill to all information workers. So everyone that works in an office or in front of a computer, the more skills you have with data, the more it will correlate with your ability to do your job, which is a great thing for us as data professionals. So democratization of the analytics process. Let me talk about this. So I think it's widely, the sentence that you've heard and overheard is democratization of access to data, right? So everyone, that's a very well accepted trend that more and more people should have more and more access to data. And that's very much a consumption related statement of like knowing how to consume data, interpret data, make decisions that are based on data. Now, the trend I'm talking about here goes wider than that. So I'm talking here about the overall analytics process, which I define as the process by which data gets instrumented, curated, wrangled, transformed, augmented, and ultimately consumed and weaved into processes, right? Like how the data flows from its creation all the way to the right place that's powering the right person to make the right decision or to power the right process, whatever it is. So I have some examples of this at a very high level. And these statements might be more or less true depending on your vantage point, but these are things that I've observed. PMs are more involved in instrumentation and measuring product impact. Engineers are more involved in instrumenting things up front, right? In terms of like collecting the right data up front. More people in different roles are defining metrics, dimensions, business rules. There's more data flowing into daily processes and operational tooling. And then there's feature stores that are emerging. I won't get too deep into that, but I think ML-minded people are understanding the importance of data engineering to achieve their data science or ML-related goals. I think I'm going to accelerate the pace a little bit too here. I don't know exactly how I'm doing on time, but I think I have probably another 5 minutes before we have a question session. So think about your questions, everyone. Here, I'm really passionate about this one. I think it's a really interesting trend. Every product out there is more and more becoming a data product, or is integrating data visualization components, interactive data viz component, has, in some cases, real-time data flowing into it. So I think over the next decade, every product out there is likely to become increasingly a data product, which has some deep implication for the role of the data engineer. So that means that instead of being more passive consumption of data at rest, we're going to see a lot more active data that's flowing, and that has to be production grade, right? As highly visible product becomes data product, the need for reliability of the pipeline, there's more tension around that. So I won't get too deep into that as I'm accelerating. Another trend, big one, I could probably talk about that one for an hour or two, but here the point being the emergence of data ops and data, here I call it data obs, which sounds awful, but I meant to write data observability, pushed by a more tension and more desire around more guarantees around data quality, right? So I think like data reliability, data quality, data like trust in data is becoming more important as data becomes more centric to what everyone does across organizations. And I think we're only going to see more data ops, data observability. You can probably do a parallel with the DevOps movement and say that in some ways we might be, maybe 5 years, 10 years behind on the data world on software engineering. I don't know if that's a true and fair statement, but in terms of like, if you look at the DevOps movement and how mature it is versus like the data ops and data observability movement, I think we're behind on the data side. And we're starting to see emergence of all sorts of tooling to make that better. This one I'm going to go fairly quickly on is this idea of the erosion of the BI semantic layer. So for those familiar with the semantic layer, for those not familiar with the semantic layer, business intelligence tools, things like Tableau, Looker, historically Business Object MicroStrategy, had this thing called the semantic, that people would refer to as the semantic layer, which is a lot of metadata around how data can be joined and used, information about metrics and labels and description. So this layer seems to be somewhat eroding away from the BI tool and moving in parts to the transform layer and other places. Well, I would say in other places, I would say the data catalog and the data discovery challenge, which is the problem space of being able to find your data assets and understand how they are related to each other, is still like a big problem space, and probably too big for any given BI tool to manage. So there we're seeing the data discovery, data graph brown moving to data catalogs type application, and things like Amundsen and DataHub that are open source project trying to solve and attack this problem. And as teams use multiple BI tools and use things like dbt and Airflow, we have to share that metadata with other tooling. And historically, the BI layer has not been open enough to provide the guarantees of sharing and integrating with other tools. So I think there's going to be a lot of work around metadata in general and metadata management. And that's going to become a primary or an increasingly in focus item for data engineers, right? To manage, to treat the metadata like it is a really worthy and a really important thing. There's a clear trend there. All right, a few more trends before we pivot into the question section. Decentralization of ownership. So that is maybe a larger organization challenge here, where what we're seeing is that we used to have central data teams that would be managing the data for the rest of the organization. And we're seeing every team becoming a data team. So that has very deep and complex implication around who manages and owns things, and how metrics dimensions are defined, and who owns pipelines that treat data that are useful to multiple teams. So over time, I think we're going from a more centralized model, which is obsolete and just as proven not to work, at least in larger organization, and into more like a hub and spoke model, which is a decentralized kind of picture in the middle there. There's this initiative or effort, I'm not sure how to call it, but this thing called data mesh that does a good job at identifying some of the challenges around this, and tries to propose some solutions. And it's unclear, exactly whether those solutions are like how to put them into practice. But it's a clear trend that we need to decentralize the ownership of data, as large organizations need to collaborate on data structures. Here, I'm going to go talk a little bit about computation framework, and this is a little bit more looking at the future. So here, there's an emergence of frameworks that are probably, let me try to describe them in a way that's like somewhat comprehensive. So you can think of maybe a framework, something like DBT or Airflow, as a place where you can define these data transformations. What we're realizing is really often these things are too open-ended, right? If you look at if the framework is you write whatever SQL you want, there's no guarantee, there's not enough constraint, or there's not enough guarantees for this to be usable. So constraints around who owns this and how things define and how are transformations expressed. So what we're starting to see is call it like layer 2 solutions on top of SQL that, or on top of SQL or other, pipeline frameworks, right? So the general idea being offering these higher level constructs and interfaces that are more opinionated as to what kind of transformation should be done and how they should be expressed. Often those are defined as SQL and YAML, where you say, here's my data set, here's the transformation that I want to apply, here's who the owner is, here's how it relates to other transformation or metrics and dimensions that exist in my data warehouse. And then these computation frameworks offer more guarantees in terms of how things get computed and what results are created. There's some good blog posts out of Airbnb around something called Minerva, talking about their metrics layer. We've seen similar things emerge at large companies like places like Facebook, Netflix, Lyft, and other places. We've seen special purpose computation frameworks, notably around the feature engineering problem, closer to ML. The metrics layer, as I mentioned, there's also other special purpose frameworks to compute things like engagement metrics and growth accounting metrics. And I'm hoping this is a place where we're going to see more reference implementation and more projects emerge over the next few years, right? So people sharing these constructs that are more opinionated as to how to do certain types of transformations. People might think like this is really ungrounded. I don't know what you're talking about. I gave some other talks in the past around this topic. Part of what I wanted to do when I created Airflow originally, I had the hope that people would use Airflow as a DSL to create these more special purpose computation frameworks. And we've seen very little of that happen. So I still think that's something we're going to see more and more of in the future. And that gets me to my conclusions slide. So talk about a few caveats I mentioned at the beginning. So first is like, things are moving really fast, and depending where you sit in the universe, you might observe completely different things. And I wanted to say too that my experience is subjective in the sense that I sit in a very not unique place, but my vantage point is from the middle of Silicon Valley. I wanted to give the pointer that there will be an upcoming blog post on this with more structure, hopefully, and more supporting evidence. So here I'm making big claims without showing data. So I'm hoping the blog post is going to have a lot of references and a lot of pointers to other articles and to data and evidence in general. And then I wanted to say, like, data engineering is still very much in its infancy, right? If you compare to software engineering, we are behind in some ways, and I would say our maturity, where we are in the maturities curve, is just earlier, and that creates a lot of opportunities for all of us data engineers. So the future has yet to be built, and I wanted to tell people, to try to inspire people to say, like, go build that future. It's not built yet. Like, we have not figured out data ops and data observability, and there's tons of tooling that we'll need that does not exist today. And I think that's super exciting to think about. With that, I'm going to conclude with just a pointer to urge you to go and try Apache Superset if you haven't tried it in a while or ever. And the best way to do that is to get started on preset, where you can run, freemium. You can get started in the next 2 minutes if you want to, and get started on preset. So with that, I'm ready to take some questions if people have questions.
I love you so much.
That's my son.
Thank you so much. I love you too.
He must have loved the presentation. So, yeah, he's a big fan, Max.
I want to make sure it was, catering to different audiences, including toddlers and beyond.
Absolutely. Glad you hit your target market. Awesome. So, Supra's mentioned that, YAML has come a really long way, and it's really nice. And I guess you've got sort of templatized. what's your thoughts on sort of using YAML as a way of a deployment methodology for deploying dashboards and the like, especially with, Superset and a preset?
Yeah, so headless BI is related, but I don't know if YAML has come a long way, right? YAML is still the same, like YAML spec from the early days. It is, I think or the tooling around the YAML might be better in terms of enforcing schemas and maybe the CLIs that expect, the command line interfaces that expect YAML might be better at kind of telling you how to structure your things, right? And the values that might be accepted or not. To me, I still find it like very, very brittle and unintuitive. Like a drop down, something as simple in the user interface world as a simple select drop down. And the YAML equivalent is like reading some documentation or trying something, and then it will tell you, the value you entered is not allocated. So it's not a great user interface. The best thing about YAML is that, and templated SQL, is that it's files and you can check it into source control, right? But is it a great user interface? Maybe. I think we're going to see more interplay. So they're going into headless BI specifically. I think we want to see more interplay between, hey, some people might want to drag and drop. Some people might want to author YAML. Some people want to check stuff into source control. Or some assets that are really important should be checked in source control. Other assets that you just save don't need to be in source control. So I think we're going to see more interplay between like code gen, or when I say code gen, I mean like YAML gen, and being able to pivot from like one side of the world, like the Git view of the world, or the kind of database view of the world.
Yeah, really cool. I guess this whole sort of templatization of, I guess, data right through the stack, from sort of data engineering pipelines to, sort of creating tables and views and things like that in the warehouse, what you see with sort of DBT and the like, and then all the way up to the visualization layer is quite an interesting concept, because it plays into that concept of data mesh and sort of distributed data teams and things like that. Mm-hmm. How do you see sort of like traditionally what I've seen with visualization layers is that it's actually really hard to migrate from one tool to another, enable sort of, usually you've still got pretty well centralized analytics teams building out the dashboards and stuff like that. What sort of trends do you see in that space? We've got a question from Shri.
Can I go back a little bit on the previous topic too, like just about YAML specifically? Airflow is like, a more of a DSL in a programming language too, right? So that means that when you call an operator, then your IDE, whatever it is, can kind of tell you what the expected value and expected schemas are. And then YAML doesn't really have that too, right? So the programming language itself, like, should you go, with something like the Airflow DSL versus something that's much more static and declarative? And to me, like, I prefer an API than a data structure, just because it's more dynamic. And if you're in IPython, you might be able to look at, the declaration. There's more semantics there. There's docstring, and there's, accepted values and types and stuff like that. All right, back to the other question. Sorry, I was like, I had more to say on that one. Yeah, let's see. Let me read. I can read. So what are your views on trends like data mesh and data fabric for decentralized data platforms? And is there a tension between independence, freedom to operate, and governance? So I did a deep dive into data mesh. I read the content that was there. I was like, oh, people are talking about this on Twitter. I should look it up. And I had trouble finding the substance of what it meant to me as a data modeler and data engineer, right? I think it makes claims around like how data should be governed and how things should be, like what things should be called. But to me, it was more confusing than helpful to look at. So I think they do a really good job at explaining and summarizing some of the challenges that large data organizations are facing. So I think that's the gift of data mesh, at least to me, is like they articulated the challenges very well. And then I don't think they articulated the solutions as clearly, right? Like when I say data product, it means very different things to me. And when they say treat the data products like they are a product that you deliver to people. I'm like, we've always done this. It's not like data engineers didn't care about delivering good assets in the past, right? So some of it is a little bit like, hey, there's not much that's very new here.
Yeah, fair enough. Yeah, I think it's still very much a concept that needs to be explored. I know a lot of enterprise folks are definitely looking at it, whereas potentially for the startup folks, it's kind of not something that they really care to think about too much.
Yeah, there's some things that stick with me, you know, from reading the material. One is being more clear about defining which data sets are public or private. I think so in programming, you might have your private interfaces and your public interfaces in your classes. So I think having this idea of declaring more clearly, like, hey, this is an internal asset to our team. Like other teams, please don't come and use this data set because we won't provide any guarantees around change management of this asset, right? This is not for everyone's consumption. It's a private thing. So there's some ideas that are pretty good around that. But when they say like, what's a data product and where does it live and how does it relate to the data warehouse as we know it, the answers that I got were confusing.
Yeah, fair enough. Rowan DePellier has asked, what happened to dimensional modeling in your opinion? Is there any value in this type of thinking still?
Yeah, I mean, I think it's super valuable to me. Like I'm a Kimball disciple, and I read all the books like 15 years ago or 20 years ago, and it's like hard for me to not think in that way. Even like the bus matrix, the dimension effect. Some things are less relevant nowadays. I could expand on that if people are interested in like. The star schema now lives inside, in some ways, the data segments and things like Parquet files, right? Like you can almost think of like every Parquet block or Parquet file being a little bit of a star schema in itself with a dictionary encoding and you know metadata in there. But no, I think it's like very relevant. I think every data engineer should read the dimensional modeling books. I don't model necessarily in that way anymore personally, but you know, I still think in that way, like facts and dimensions. There's something that I like to talk about is entity-centric data modeling, which is when you think about it, it's like, oh wait, that sounds like dimensional modeling because a dimension is an entity. But when you think about what a feature store is and what is a feature store is like you take an entity like a user ID and then you put a million columns and some of them temporal, some of them metrics too. But like I like to push the idea of entity-centric data modeling beyond the attributes of the dimension and bring a lot of metrics that are time bound into it. 7-day visits, 28-day visits, you know, like all sorts of these metrics, denormalizing metrics inside the entity tables or the dimension tables.
Yes, absolutely. On a kind of similar topic, well, leading on from feature stores, Olga's asked, are there any new trends specific for machine learning in terms of data engineering that are different from other data engineering evolving in general?
I think so. I mean, I think what I just talked about is it's almost like I knew what the question was coming, but I think like entity-centric data modeling is a very valuable and important thing. Just to think about your entities and how you bring all sorts of features to it. Is there more to it? I think that data scientists and the feature engineers, the people who work on feature engineering need more guardrails and probably a computation frameworks, like something that is not just like the tools that you give them is not just like SQL. Right, it's like it's probably like more like SQL and YAML with like, you know, probably semantics around doing these time metrics. Pivot, I'm not sure. Like probably people hear that like, what the heck does he mean? But things like being able to say like, so say for preset, it might be like looking at the number of like 28-day dashboards created by a certain individual, right? Or like the number of like life to date, you know, visits and things like that. So these like time-based pivots that become feature associated with the entity.
Yeah. So yeah, and specifically on just finally with sort of I guess the dimensional modeling, how do you see, like, it's going back to a bit data mesh? Data mesh is kind of talks about domain driven design, and do you see, as folks are embracing DDD a bit more, do you see sort of dimensional modeling still being required in that sense, or do you feel
you said DDD? I think I missed that. Was
domain-driven design?
Oh, okay, domain-driven. Well, so I think like the idea of subject areas and data marts is not new either, right? So if you start thinking about the bus matrix, and we're very much facing these challenges, at all of the data organizations or the companies I worked at. But if you think about the bus matrix, or essentially like you have metrics and dimensions, there's kind of no way around that, right? Like you're going to have some metrics and some dimensions, and then you do this matrix of like groups of metrics, groups of dimension. You have to start thinking about who cares about the intersections of certain metrics with certain dimensions. So you could say like at Airbnb, it might be bookings by country. A lot of people care about bookings by country. But if you look at bookings with a bunch of like fraud related information, like the fraud team kind of cares about a certain set of metrics at the crossing of certain dimension. And I don't think it's like you can just go and draw circles in this multi-dimensional space and say like, these people care about this, these people care about that, and someone's going to own, something, and someone's going to own another. So this part too, it's like I would say like the data warehouse or the data mesh, if you call it that, right, should be a reflection, kind of a mirror of the organization and how it thinks about data. So the organizational structures in the company need to be reflected somehow in some ways inside the data warehouse, inside the data structure. And the reality is no team work in isolation. Teams work together and they share, things they care about. So how to make everyone work together? Probably I would say hire more data engineers, create a space for them to collaborate, get them to work together and figure out what works. And hopefully we can get more structure and tooling, that embodies some of these ideas over time.
Sounds like, it's super inspirational stuff. It sounds like it's almost like a call to arms. It's like, come on, let's get building data engineers. So thank you so much, Max, for joining us at the conference. Really, really great to hear from a thought leader such as yourself. So absolutely honored. Thank you.
It's a pleasure. If I have a closing thought too, sometimes people think like, people assume and have accepted that software engineering is highly complex and requires a lot of very smart people to put a lot of solutions into place. And then we think like, data should just be easy though. It's someone else's job and a small team should be able to do it. So as data engineers, data practitioners, I urge people to kind of raise the level of attention to say like, data is just as hard as software and these things are connected. And it won't be solved by a magic framework or a magic one or a magic tool. We need the kind of level of solution, complexity of solution that we have on software engineering, we need on the data engineering side.
Absolutely, couldn't agree more. Thank you so much, Max.
It's a pleasure. Thank you, everyone, and go build the future.
Awesome. Thank you. Wow, that was a super impressive keynote from Max Berchemont of Preset. He's got a fantastic new product based on Apache Superset called Preset Cloud. So go check it out. Build some really cool dashboards for all your data engineering use cases. But up next, we've got Stephen Bailey. Stephen Bailey is the Director of Data and Analytics at Immuta, the leader in Universal Cloud Data Access Control. He's played many data roles, scientist, engineer, analyst, and data janitor even. So he's got a passion for learning and sharing with others, especially those trying to break into the data field. So I think it's going to be fantastic to hear from him. And so without further ado, we will bring him into the stream.
morning, everybody. My name is Stephen Bailey. I'm the Director of Data and Analytics at Immuta, and it's my pleasure today to talk to you about something that I think is really important, but data governance in the modern data ecosystem, and specifically around problems such as privacy and why data engineers need to be leaders in creating solutions that companies can actually implement in order to control these problems. I've split the talk into 3 topics. First, to just draw some parallels around the new data ecosystem and previous technological transformations and what we might need to adapt in this new ecosystem. Secondly, to think through some of the major players in how companies manage risks like privacy loss, and really dig deep on who is positioned to lead those initiatives. I don't think it'll surprise anyone to hear that it's going to be the data engineers. And then finally, to look at one specific area of modern data governance where privacy can be protected, and that is access control, and how metadata can play a key role in scaling that across your entire ecosystem. So let's first talk about the risks and opportunities in the new data ecosystem. I want to start with an analogy. So 150 years ago, the steam engine was a technological marvel. It transformed the economies across the world and really was a key piece of the industrial age economies and the innovation therein. I think there's some really interesting parallels we can draw between the steam engine and maybe the first era of data. If you look at the steam engine, it's really a monolithic design. You have an inseparable relationship between the infrastructure and the vehicle. The cars, or really the value drivers, are attached to that steam engine, and that steam engine has to be managed by a single experienced professional driver. Everything has to be thought through. Like, you can't just, you can't just dream up a new railroad track and in 2 weeks you're going to have a train driving on it to another city. It's got to be there's a very high planning and implementation cost. If you think about our modern transportation ecosystem, you have this total separation of the infrastructure from the vehicles that are driving along it. And that decoupling facilitates just a much larger quantity of automobiles that can drive on, and also a much larger variety. So you have everything from, taxi cabs, bicycles, motorcycles, personal cars, trucks. Really, if you wanted to, you could drive a tank down the road. There's not really any relationship between the infrastructure and what's happening on top. That's led to a real democratization of the personal automobile. So pretty much anybody can pilot one of these very sophisticated vehicles without an incredible amount of training. And it works. It works, and that's why it's spread and been so impactful. Well, I think that, like our roadways, the modern data ecosystem bears a much closer resemblance to the modern roadways than it does to train tracks. There's no clear boundaries of responsibility anymore. The ease of portability, transformation, and the variety of tooling means that data consuming tools can quickly become data providers as well. It's all about interoperability. There's not a single monolithic data warehouse that the company took 3 years to plan and built a team around and hired very specialized people to manage it. In basically 2 weeks, a team could decide that they want to spin up a Snowflake database, start ingesting data into it, and have like 15 SaaS apps connected, and delivering high quality data into an analytic tool. It's the world has really flipped on its head. One consequence of that is that the variety of tooling that's available and the complexity of the whole ecosystem has exploded. This is a diagram from an Andreessen Horowitz article on H16Z that shows the modern data ecosystem. You can see from left to right at the top, there's a general pattern here of like you have data and sources, you transform it, you store it, then you can do like certain types of analyses on it and it outputs in a dashboard or a report or something like that. But there's bidirectional arrows everywhere. You've got things like feeding into each other from within the same area. It's chaos. Not unlike New York City at rush hour. It takes a trained person and someone kind of brave to want to drive around in New York City at rush hour. Someone certainly braver than me. But the same is true for people who want to start digging into and innovating within a modern data ecosystem. One of the big points here, though, is that it's not like highways, it's not like it was just a technological transformation that took us from trains to cars. There were a lot of changes to the infrastructure, the way we build cities and the way we plan cities. A lot of changes to oversight and supervisory capacities. We have patrol cars and emergency services, signs everywhere, stoplights. And we have processes. So human behavior, it's a big thing when someone becomes able to drive. We could make getting access to the warehouse a big celebratory thing. Like, hey, you've become a power data user and you're like special now. Car insurance is another thing. It's like these whole industries have built up around in order to make riding on this infrastructure safe. In the same way, we need a better way to govern the whole data ecosystem because there's so many new risks that are posed. The title of this talk is specifically about privacy, but and that is probably the most prominent human issue that's at play. People's personal data is just scattered through all these systems, and that can present economic risks. Where if the data is not high quality, if it's not protected, company can get fined. But also culturally, like if we feel like a company feels like they're not protecting employees, or if they're like abusing employee data or customer data, that is unsettling. And human risks. So there's real costs to privacy violations, security breaches, and unethical use of data to the people whose data that is. So our world has changed, but I would say our sort of mental template as a community that uses data has not changed along with it. And we need a better way to govern this data ecosystem to minimize all these risks. So who are these people who are going to be able to improve our data governance standards to help us create safe roadways for leveraging data to bring as much value as we really want to get out of it? Well, there's at least 4 big sets of players that I've listed here. On the left-hand side, we have regulators and lawmakers. These folks are trying to create far-reaching standards that can be broadly applicable. The sort of things that come to mind initially are GDPR, HIPAA, California Consumer Privacy Act. These big regulations, they set the standards that companies have to start adhering to. But they also might miss the mark on being very prescriptive. So there's a lot of holes that have to be filled in. The next group is compliance and information security. They set company processes, they set standards, and they audit adherence to them. There are internal enforcement of the company's stated standards and agreements with external companies, whether that's regulators or auditors. The next group is business owners and data consumers. So the people who are in the trenches, creating, producing, procuring, bringing value out of data assets across the company, basically the ones who are getting a return on the investment in our data assets. And finally, we have data engineers and platform owners, the people who are mostly technical. Their concerns are about building platforms that can drive value across the organization, either internally or also externally, more and more. Well, let's talk about like what the limitations are with each of these groups. So for regulators and lawmakers, they might have a great standard. They might even be aspirational, ambitious, that we want to create a country that protects people's data. But there's a lot of gaps to fill in. They might not have an implementation plan that's ready to go. Some things like anonymized data might not even have a clear definition that engineers can just go through and implement. Compliance and information security, similarly, while for areas of the business that have been around for a while, or for very clear external standards, they might be able to put into the place a very clear process. A lot of the stuff that's coming down the pipe in the new data ecosystem is brand new. There might not be a playbook out there that the company wants to commit to following and building a really, really strong process around. Things like fairness, the exact definition of what is identifiable data and how that should be handled. There's a sort of a softer layer right now as new things come out that compliance and information security may not be yet able or ready to build a process around. The business owners and data consumers are so focused on bringing value to their projects, to their lines of business, that they may not operate with the whole big picture in the mind. And they also may lack some of the technical skills around how to make a scalable system. And so even though they might be key partners, they may not be positioned to create standards that scale. And finally, the data engineers and platform owners, these are the people I think that are really equipped to bring a modern data governance at play. They're experts at architecting systems. That's their job. They sit at the cutting edge of technology. They're always looking for new things coming down the pipe that are going to generate value. And they're incentivized to build for scale and reliability. They are not incentivized to solve today's problem. They are really thinking long-term and big picture, hopefully. There's a great quote from this book, Data Management at Scale, that talks about how a large part of data governance work involves defining principles, policies, rules, and standards that fit the enterprise's goals and risk appetite. And these principles, policies, rules, and standards, they have to be enforceable. They have to be implementable. Otherwise, they're just pieces of paper in a drawer. And I think only data engineers are technically equipped to operation and scale principles, policies, rules, and standards. The new data ecosystem presents a lot of technical problems that have to have a technical solution, or have to have a solution that's at least technically sound. It's not going to be, a simple like data catalog or Word document that everyone puts in their data assets and what data is sensitive. There's got to be real technical backbone to any solution that comes out here. So when we think about privacy and we think about all these interrelationships between systems, where does privacy protection happen? Does it happen in any like a single node in this graph? Well, in this article or in this diagram, there's 4 things that I would call governance functions, governance capabilities, and they're all kind of situated at the side of this diagram. They're broken into metadata management, quality and testing, entitlements and security, and observability. And I think what you'll see, if you think about it, is all of these things have to do with principles, policies, rules, and standards, and they're also driven by metadata. Quality and testing is you're creating a metadata, a framework that you want to evaluate data assets against. Metadata management is all about defining and coming up with vocabularies and discoverability of assets using metadata. Observability is about, about looking at all of the things that are happening across all these different pipelines and coming up with actionable intel. And then what I'm going to drill in on is entitlements and security, which is using metadata to enable access and protect assets, using metadata about who people are and what they're trying to access, and enforcing policies based on it. So in other words, data engineers, as they think about their entire data ecosystem, they need to be thinking about the metadata layer that is one step above infrastructure, but one step below the actual data products. All right. So to close out with, I want to dive into one area, which is our company's specialty at Immuta. We focus on entitlements and security and how metadata can drive these policies to make it a more scalable system across projects, across technologies, across policy types. And one thing I want to point out here is that access control is really one of the original metadata-driven governance problems. When you think about early databases, what's one of the first things that they put in there? It was roles and groups about who belongs to what and what they can access. And a lot of times these were baked directly into the database because you only had one database. In the modern ecosystem, you have an identity manager that might be federated across all of your systems, soaking in data and like powering access to different systems. That's really the starting place for a modern entitlements and security solution. And so I want to talk about three things that if we focus on building a really robust metadata layer, there's a couple of things we can accomplish. The first is we can abstract access policy from underlying technology and projects. We can establish a better language around what we're doing. I think that's one thing that's very underrated is the language that currently exists around access control is so hard to understand for a regular person. Metadata can help make that more accessible. And then dynamically injecting context into control systems to make them much faster and more dynamic. So when we think about putting policy, applying policy like, hey, only certain users can access personal data, a lot of times we think about the transformation layer. So in a lot of data pipelines, you have transformations that are designed to make a product better, like standardization, aggregation, data cleaning, denormalization. And a lot of times personal data protections will be like kind of baked into the product there. Or they'll be baked into like the report that's generated at the outside. These types of baked in transformations, I'm calling governance transformations. They're things like access control, row level security, identifier masking, data minimization, even higher level things like k-anonymization or differential privacy. And I want to walk through a scenario where a team kind of grows up, a small team kind of grows up, and show you the pain points here. So at a small scale, teams can get by with having almost no access control. So here we have a database, you got bronze data being transformed to gold data, and it's being released basically to everyone in the company because that's what you do when you're small. Oftentimes you'll start saying, hey, we've got some data we need to start protecting and only the executives can see it or only a certain group can see it. So you start breaking the gold data apart into two and you give different people access to it. And then there start to be more requirements that start coming up. So you might have to restrict access to some resources, sometimes only for certain projects or certain reports. There might be another group that gets involved. And so basically complexity starts getting built into the pipeline. But if you are able to defer the policy implementation until later, either through, what I'm showing here is the Immuta policy engine, but there's a lot of other tools that are coming out, even those kind of managed by the cloud data warehouses. You're able to abstract the transformations from the transformations for governance from the transformations for utility, which simplifies access to all of your interested parties. Similarly, if you're thinking about a warehouse that you've implemented some controls, you're happy with it, But then, your vendor increases prices, or you're spending way more than you expected to, and you want to switch to a different system or switch some of the workload. Well, all of those transformations that you've put into place here now have to get retranslated into another database language. They get re-implemented. You're now governing 3 systems. That creates a lot of challenges. But if we treated governance transformations in the same way that we treat identity management, for example, then you should be able to push down these transformations into a single access layer that allows personal data to be masked. But it's all dependent on being able to tag or identify certain types of data across platforms and then implement a rule specific to that type of data on those platforms. But you can see the clear value add. Secondly, policy can become very complex. And one of the best things that you can do as an organization is to have clear guidelines around what is expected of data products, who can access these things, what they are, and what you mean when you say, for example, personal data or sensitive data. It's not a trivial task to come up with this definition. A mature metadata framework is going to have things like, it's going to enumerate exactly what you need to be concerned about and what needs to happen with that type of data. It's access control models, one of the most familiar one to most people is role-based access controls, and that can get you a good bit of the way. Attribute-based access controls, as you can see on this diagram to the right, allow an increasingly finer granularity of access controls, because instead of focusing just on roles, you're focusing on, you're actually defining the objects and the attributes that need to define that need to power the rules. So they enable more complex policies at a finer granularity, but they also can be more readable as well. But there's another class of access controls where you start implementing policy-based access controls, where you're giving a more transparent rationale for access decisions, and they're easier to follow. So a lot of times they'll implement attribute-based access control rules, but they're providing a reason and a rationale for why they're being implemented. And that's not negligible. That value add is not negligible. The clearer we are with why we're doing something, the more likely it is to be followed, and the easier it is to onboard new people into that system. And the proper metadata framework can really allow a lot of flexibility. This is an example from our Immuta policy engine, where you can really understand what's happening here. So in the second line item, we're masking columns that are tagged a direct identifier by making it null for everyone except when user is acting under a certain purpose. So it creates a much clearer policy than some allow, accept, block, IAM policy, or IAM policy. And finally, my final example is I want to talk about context. One of the things that we don't talk a lot about, but is written into a lot of these laws is you have to actually be thinking about why data is being used and tracking that. You can't just use data for any reason. Although we have some tools at our disposal, things like roles, it's very hard to understand why a certain data analyst was using a certain piece of data and then attribute that. There are let's say organizational ways to handle this. In academia, you have institutional review boards. There's data privacy impact assessments that can, outline why and how data will be used and what the consequences are. Certain projects may be amenable to things like model cards and data sheets, which are really great tools for identifying risks in data. But we don't really have a standard way of going about doing and evaluating why data is being used. And a dedicated governance layer can start to enable that. If people in the Immuta product, there are concepts called purposes, which users can switch into and out of, and they will actually enable access to certain data assets or enable access to some forms of personal data of access. So for example, if you're acting under an analytical purpose, you might only get fully anonymized data. Whereas if you're acting under an auditing purpose, you could get access to data that is fully like in the clear. And it also gives a hook for data governors to kind of step in and review an access request. So building in workflows around access control allows us a lot better. It gives organizations a way to step in and make decisions about when and how data can be used. All of these innovations are reliant on metadata. You have to have your policies defined, knowing what you want to do. You need to have a comprehensible language around policy that everyone in the company can rally around, and you need to be thinking about like what are our workflows and processes, and when should data be being used for a certain purpose. And if you unite them in a metadata solution or a data engineering, a metadata solution that is scalable and robust, that is battle hardened by data engineers, well, now you have a real good entry point into modern data governance. And the same can be true for these other capabilities: metadata management, data quality, observability. All of these things are important to ethical use of data, and they need to be prepared to scale along with the organization, because we're in a new data ecosystem, and it presents a lot of technical challenges. Just a closing thought, as we think, just like roadways, the future for all of our organizations is connected. All of this data sharing initiatives means that we're going to be driving on each other's data highways sooner rather than later. I've gotten a lot of requests from vendors who want to do data shares with us, and instead of going through an application, we're just going to share data directly. We all need to start thinking about the conventions that need to be established so that we can maximize value and minimize risk. I think that only data engineers are the ones who are capable of coming up with those standards and principles that can then be enforced and followed by other stakeholders in the ecosystem. But it's really on us as technical professionals to be leaders in figuring out what's going to work well so that we can all participate in this new economy safely. Thank you so much.
Welcome, Stephen. Thanks so much for joining us. It's pretty late over there, isn't it?
Yeah, it is. But it's great to be here.
Yeah. Really, really excited to have you. I guess attribute-based access to data stores and thinking about privacy. It's, traditionally it's just been hard enough just landing the data in the warehouse and building data pipelines, and we've got all of these great tooling that's automating a lot of that work these days. And I guess now it's time to really start considering deeply, how to store that data securely. I'm guessing a lot of us already have been thinking about that deeply, but I guess also on top of that, who's got access to it, how to share it securely. I know a lot of the cloud providers are providing ways that you can sort of do data shares and things like that. And so, take us a little bit through kind of who Immuta is and what your product is. We're not a sales pitch or anything, but it's interesting because it's a fascinating tool and stuff like that. So what exactly does it do?
Yeah, I think the thing that I would love to just, bring up and along this topic is just, I feel like we've revolutionized the way we ingest data in the warehouse, how quickly and easily we can move data from point A to point B and like put, deploy an ML model and all this stuff. But then I feel like when it comes to governance, it's sort of there's this sense that it's someone else's problem. It's always, someone else is always going to do it or have the final say. And so, we just kind of want to manage the system and like make it ready for whatever business, arbitrary business rule comes down or anything like that. But I think there's so many interesting technical problems in this governance space. I mean, with the explosion of SaaS applications, your points of vulnerability for data leaving your platform are, growing astronomically. And now you've got to, federate identities across all these platforms. And, I could kind of like, how are we protecting that data that's moving through those things? It can't just be this discussion of like, well, is it encrypted at rest and in transit? It's kind of it's not that black and white when it comes to identifiability of data or the risks of harm for deploying a certain type of data model or sharing certain types of data. And, I'm starved for like conversation on this and like productive conversation, I should say, because I think there's lots of conversation, but it's so hard to start figuring out what is the point of leverage, highest leverage from a technical perspective and start getting some traction there. I know Immuta has a very access control specific point of view on things. Really, we really are an excellent fit for use cases where there's lots of policies that are coming by. There might be a lot of a number of cooks in the kitchen, so to speak, with different business requirements. Maybe each department only wants to share a subset of their data, and they have their own rules and they want to audit access to that. And so it's very much about this sort of managing this many-to-many relationship and trying to maximize availability of data while minimizing risk. But like I talk about in that discussion, I think it's not you can't solve the access control problem without solving the metadata, the language problem, right? Because if the one department defines their, calls their personal data, PII, another department calls it personal dot, European person, or like one department cares about localization, another department doesn't care. Like you have to coordinate. It requires a lot of coordination and then technical implementation along with it. So it's it's all interconnected.
It's fascinating you bring that up because we've had Juliana just chime in. She's saying we've just started working with Immuta and so far seems pretty flexible and helpful for decentralization. We're not trying to do a massive sales pitch once again, but it's interesting that some of this new tooling can help with these concepts. But you talk about sort of standardization and things like that, and maybe sort of data mesh gets brought up from time to time, and sort of having these common patterns across teams and having decentralized teams, and how tools like Immuta can help with, I guess, and how can Immuta help? Obviously, it solves the access problem in a decentralized setup, but I guess the sharing of metadata and how you sort of publish, is it that you have a contract, that it says, hey, and metadata needs to be in this format, with these sort of names being used and things like that for PII information. And
it kind of ends up being a policy is sort of this intersection of, we have the what needs to be protected, so the data, the who of who's accessing it, where is the data located, and how do we like get controls into that place, and then also why. So when we think about a good example is like consultants who may be able to access data for a certain project only for that project and not for another project. So how do you actually go in and implement that in a system? And something like Snowflake, you could have a role that allows a user to switch into it, and then they access it, and then you kind of audit that they're under that role. But then if they need to access that data in another system, or they're, if do you have to recreate all those roles in that other system, or can, how do you sort of manage that complexity as these rules start to increase in your organization? And I think what's kind of interesting to me, because I run the data team at Immuta, and we're still a small, mid-sized startup now. We've got about 200 employees, and so we went from being able to make a lot of decisions independently, on our data team, to now, okay, we're starting to get the organization involved, and then I can see a point in the very near future where, oh man, we're going to have a lot of rules, we're going to have a lot of process, and it sort of just hits you in the face, because as the data guy, it's like, in all these communities, I'm not hearing a lot of conversation about like, hey, the best practices for doing data governance and scaling up your rules are XYZ. Hey, make sure at step 1 you have all of your data tagged in a certain way. No, we just aren't seeing those conversations. I don't feel like we have that playbook quite out there yet. But then the pain, once you get to that point, is very real.
Yeah, I can imagine. Maybe it's just kind of tightly held within some of those enterprise organizations that have felt the pain and come up with solutions. I think it'll be interesting to see if anyone sort of open sources a set of standards in the future. I know that there's the Open Data Lineage API that's just been released.
Yep.
But yeah, definitely sort of in terms of column naming conventions and the like, and that sort of jazz. I think that'll be fascinating.
And I think there's a lot of opportunity here too, just from sort of at the simple, there's a lot of low-hanging fruit. If data teams are using Fivetran or Stitch or Airbyte or Meltano, like these data loaders, every one of them has a very clearly defined schema as data is going into your system. Not one of them shares a common language around, hey, this is what we call personal data, or like this is how we're going to talk about addresses. So we have a lot of rigor. Data engineering community has a lot of rigor around like data types, and there's no analog for the semantic types, of metadata that could be sensitive that are getting into your organization. And hey, how do you make sure that doesn't go into dev and things like that? There's a lot of practices that I feel like we could build if we start having the conversation in public and coming up with rules. I love the Open Lineage project. We do a lot of stuff internally with that data model, and I think it's a step in the right direction for sure.
Yeah, awesome. Another way to sort of collect metadata is using tools like dbt and the like. Have you had much luck using dbt, and how sort of like Immuta could leverage something like dbt to the tagging and the column name definitions and things like that?
Yeah. We recently released a dbt cloud integration that allows that metadata on models to just come straight into Immuta, and then kind of unlocks that puzzle piece of the policy, right? So instead of running a post hook macro or an on run in like macro that implements a masking policy, through dbt or some other way of masking data, the Immuta layer is an abstraction on that, lets you manage your policies separate from where you manage your data. And so if a governor needs to come in and audit it, or a security person who doesn't really want to think about YAML, SQL files and dbt project, they have a place to go where they can look at and audit access, and then it just kind of in whatever your cloud system is. In many cases, the policy just gets enforced kind of behind the scenes. So it's pretty neat, but it's exactly that sort of like symbiosis where you've got metadata somewhere else. Like, let's leverage it to make the business process more scalable and more well adhered to. I think ultimately, like, that's what we're all after. Everyone wants to protect the data. We just don't want to do it in a way that requires someone to print out a 10-page policy document and then fax it to us. It's like, yeah, we want to do it in the way that makes sense given all of the innovations that we're putting into all of our other parts of the stack.
Yeah, the lightest touch possible way. Well, Stephen, I think we could have chatted for like absolute hours with you on this topic. I think you've delivered a real call to arms to get us go building, sort of coming up with solutions and really discussing this, in forums and the like on how we can solve, especially the sort of column name definition type, standardization, which I think will go along, a very long way to helping. Tools like attribute based policies becoming more commonplace in the wild. So yeah, really excited to hear from you, Stephen, and thanks so much for joining us.
Absolutely. Thank you all for listening. This is awesome.
Cheers. Thanks, Stephen.
Yeah.
Okie dokie, folks. We're just going to break for a couple of minutes. We'll be back at 11:50. So just feel free to hang tight, and we'll be with you shortly. Great. Welcome back. My name is Peter Hansen, one of the organizers of DataEngBytes. Our next speaker, it's time for our mid-morning session. We've got two awesome machine learning engineering talks for you. Xin Liang, she's from ELIZA, based in Melbourne, Australia. She's a machine learning specialist, doing lots of great work in the space as part of the ELIZA consultancy. Hi, Simon said hello. I was like, is my microphone not working again? But yeah, no, it's all good. Without further ado, we're going to learn from Xin about the journey of a machine learning model from development to production. I think that'll be awesome, actually seeing how to get a machine learning model out in the wild. So that's going to be really cool. I am going to get things underway, so stay tuned.
Hello everyone, I'm Xin. I'm the lead machine learning engineer from ELIZA, and I'm also the tour guide today to take you on a journey of a machine learning model from experiment to production. So welcome on board. First, a quick journey of myself in ML. On the left, it is a picture of me on a typical pre-COVID day at work, enthusiastically putting machine learning model into production and teaching my machine to learn. On the right, it is a picture of me on a post-COVID day at work from home, doing pretty much the same thing. I started my ML journey as a product engineer graduate in a mining technology company, developing machine learning models to classify operation types of heavy mining machine. Then I moved into the startup world as a software engineer, developing image search engine and speech analytics engine using computer vision and natural language processing techniques that I pick up along the way. Now, I spend most of my time thinking how to operationalize machine learning solutions at scale. Having been enjoying software engineering for some time now, I would like to think the development of machine learning solutions is like an extension of the development of software application. Putting machine learning models into production, so-called ML ops, is like putting software application into production, which we know as DevOps. So from DevOps to MLOps, what is MLOps exactly? This is a definition from Wikipedia. MLOps is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. The word, it is compound of machine learning and the continuous development practice of DevOps in the software field. So why MLOps instead of just pure DevOps? Machine learning systems consist of not only code, but also data and models. Machine learning applications include not only deterministic components such as code, but also non-deterministic components such as model experiment. And machine learning projects are conducted by hybrid teams, including not just engineers, but also data scientists. Due to all these characteristics of machine learning practice, and unique life cycle management, it is required from data, model, and code to governance, orchestration, deployment, and monitoring. And machine learning system also requires a unique workflow from experiment to deployment. And unique development process is also needed to facilitate hybrid teams. Therefore, MLOps is born. Today, I'm going to use a natural language processing 101 model, sentiment classification on IMDb movie review data, To illustrate the path a typical machine learning model travels through in the MLOps system. The journey includes several stops. They are experiment, test, release, deployment, and monitor. Experiment is our first stop. Think about when you do software development, you have the function logic in mind and want to test that logic. So you write some code, run it locally, and test it, see whether it works. If it does, commit it to the source control repository. Similarly, during model development, we need to train a model with different feature data as well as model configurations on top of the function code. Once the model is trained, we would like to test it and see how it performs when making predictions. This process, it is iterative and it is called experiment. We would also like to track all the experiments that we run during the model development process. In order to track them, there is a component called experiment tracking in the MLOps system to provide a platform for us to capture all the relevant information and metadata in all the experiments that we run during model development. Here is a code snippet to show how we track experiments during model development. A Python decorator can be used as part of the experiment tracking framework to define and abstract the tagging scheme. For example, the experiment job type, experiment run type. And during model training, the model training configurations are logged to the experiment tracking platform. And also the model training metrics are also logged to the platform via callback functions. And after the model is trained, we have a trained model and its artifacts. They are also registered to the experiment tracking platform. There are lots of experiment tracking platform as the managed services out in the market. And the one that I used in this example, it is DataEngBytes. And here's what it looks like on the platform. We have the experiment tags, we have trained as the job types, we have all the training configurations for the trained model, and we also have the training metrics generated from the model via callback function. A typical experiment workflow consists of 3 main steps: data preprocessing, model training, and model evaluation. And here shows how the tagging and the metadata logging schemes work. At each step, we would like to log relevant information and track them onto the experiment tracking platform. For data preprocessing, we typically log the input data set or its reference, the split output training data set or its reference, the evaluation data set or its reference. And also we would like to log the feature schema of the dataset as the artifact. During model training, we typically log the training configurations, the training data or its reference, the training metrics, as well as the model output or its reference. If we have a trained model and its artifact, we will also register them as the artifact from the model training step. For model evaluation, we typically log the model evaluation configurations, evaluation data or its reference, and the evaluation metrics. Sometimes we also have artifacts from the evaluation process, such as the confusion matrix or a histogram plot, and we log them as artifacts for the evaluation step. This is what it looks like after the model experiment and development. With all information captured in one tracking platform, we can better keep track of what experiment we have run. We can easily identify which experiments produce the best model, and we can also easily reproduce all the experiments that we have run in the future with great traceability and reproducibility. After we have discovered the right approach with the correct model architecture and with the right model configuration to solve a specific problem, the model will travel through to the next stop to be tested. This is the model evaluation component in the MLOps system. When doing software development, we have unit tests to make sure that our code behaves as expected. Similarly, during model development, we also have a model evaluation to assess the model to make sure that its performance of the prediction behaves as expected. The model evaluation component has been considered in the experiment workflow, and the model evaluation metrics are also recorded to the experiment tracking platform. The evaluation metrics are typically compared against a predefined measure of success, for example, a model accuracy threshold, to make sure that the model evaluation passes the test, or otherwise it would fail. And here's what it looks like after the model evaluation being tracked. We have the evaluation as the job type. We logged all the evaluation configuration as well as the metric. Once we have the model developed and quality assured, it reaches the release stage. During software development, we have a release or a continuous integration pipeline. The pipeline typically includes the build and test steps. For a model release pipeline, it usually includes build, test, and train steps. Even though there's a trained model from the experiment workflow, it is always a good practice to trigger the training pipeline again to make sure that the model to be deployed to production is trained on up-to-date data with the latest code and configuration committed to the source controlled repo. A typical model release or continuous integration pipeline includes the build step to package the code and build the training pipeline component, test step to test the code, and a train step to trigger the training pipeline. The execution of the training pipeline is actually run on a orchestrated pipeline platform, which is another component in the MLOps system, separated from where the CI pipeline is run. The steps in the training pipeline are those occurred in the experiment workflow, but those steps are run during the release stage as part of the training pipeline instead of the experiment workflow to make sure that the trained model generated from the pipeline is up to date for deployment. And this is the model release system diagram. We start from the top right corner, the CI pipeline. I used GitLab Runner as my CI pipeline for this example. It goes through the build, test, train steps and trigger the training pipeline to run on a orchestrated pipeline orchestration platform. I use Airflow as the pipeline orchestrator running on the cloud compute resource. And the steps in the training pipeline are the same as the experiment workflow. And similarly, we would like to track the information and metadata generated from each step at the execution of the pipeline. And here, the information are also logged to the same experiment tracking platform as that is used in the experiment workflow. And here shows the similar information tracked from the training pipeline execution to the platform. There's few things that I would like to mention is that the tagging scheme is different for the training pipeline compared to that of the experiment tracking. Here we use the release pipeline tags. The information logged to the tracking platform from each step are combined as one pipeline run instead of separate experiment runs. Model artifact and a trained model generated from the pipeline are logged to the experiment tracking platform, which will be the artifacts to be deployed to production. The model evaluation metrics are logged to the tracking platform as well, which will be the metrics evaluated against for deployment. Here's what it looks like on the experiment tracking platform after the release stage. We have the pipeline tags and all the information from different steps in the pipeline logged into one run, and the evaluation metrics also registered in the tracking platform. And also the model artifacts and the trained model are also registered onto the experiment tracking platform with proper versions and tags. After the release stage, the model is tagged for deployment. During software development, the deployment or the continuous delivery pipelines typically includes review and deploy steps. For model deployment pipelines, it includes evaluate, build and test on model components, and deploy steps. And here it is the model deployment workflow. The CD pipeline has a evaluate, build, and the deployment steps. At the model evaluation step, the process is either manual or automated to check whether the model evaluation metrics meet the predefined criteria. If it does, it will tag the relevant model on the experiment tracking platform for deployment. At the step of building and testing the model component, it will retrieve the relevant model tagged for deployment from the experiment tracking platform and package it with the function code into a deployable component before deploying it to the target environment, whether it is staging or prod. And this is the deployment system diagram starting from the CD pipeline on the right. It goes through the evaluate step to check whether the model evaluation passes or fails. If it passes, then it will tag the model to be released and deployed on the experiment tracking platform. If it fails, the CD pipeline would exit. The build test steps will retrieve the model artifact tagged for deployment from the experiment tracking platform, package it with the function code into a deployable component, and at the deploy step to deploy the component into target environment for model inference. The journey of a machine learning model doesn't just stop at deployment. Once the model is released into production, a monitoring component is crucial in the MLOps system to ensure that the model in production behaves as expected. After a software application release into production, there is logging and monitoring in place to catch all the unexpected behaviors of the software. Similarly, model monitoring is required in production to capture all the unexpected elements in both the incoming data for model prediction as well as the performance of the model prediction itself. In the monitoring component, there are certain information or metadata that we like to keep track of and also log them to the same experiment tracking platform as that is used in other components in the MLOps system. The information includes the input data distribution to track whether there's data drift, the prediction distribution, as well as the model performance evaluation to make sure that the model produced the prediction as accurately as expected in production. It is noticed that the tagging scheme for model monitoring is different. We use monitoring tags here as opposed to the other tagging schemes in the other components in the MLOps system. And here's what it looks like on the tracking platform. We have the production tags for monitoring, monitor as a job type, and all the information of the data and model prediction at inference time logged to the platform. As you can see, I have the input data here, and which is the average length of the text for the movie review, and the prediction accuracy, as well as the prediction probabilities or the confidence score of each model inference. To put all the steps that the ML model travels through together, this is the MLOps system diagram of the model journey. We start from the left here, where experiment and development happen. We track all the experiments at each step and log them to the experiment tracking platform. Then the model went through the CI pipeline for release, and the CI pipeline also triggered the orchestrated training pipeline to generate the model artifact and register them to the experiment tracking platform. Then it went through the CD pipeline to retrieve the artifacts from the platform, packaged it with the function code into deployable component, and then deploy it to production. Last but not least, its operation was also monitored in production with the monitoring component. On the occasion of a noticeable performance degradation in production, the monitoring component will either trigger a orchestrated training pipeline to retrain the model with more recent and up-to-date data, and then the model will go through the release and deployment stages again. On the occasion that the model needs further development and improvement, it will go back to the experiment and development stage and to improve the model before it can go through the whole journey again to be deployed into production. This is the overview of the journey of a machine learning model from experiment to production. There are a few takeaways that I would like to mention here. A machine learning system consists of experiment tracking, pipeline orchestration for model development, automated pipelines for model deployment, and model monitoring in production. The journey of a machine learning model from experiment to production is the essence of MLOps. MLOps is a set of practices, includes the establishment of technical component as well as the process and workflow of the machine learning practice lifecycle. The complete journey of a machine learning model, it is not only the result of a technical system, but also a cultivated culture in machine learning practice. And thank you so much for your time.
Awesome stuff. Hello, Shin. How's it going? How's the weather down in Melbourne? Sunny Melbourne today?
Hey, Peter. Well, I'm looking out of the window now. It's not too dark. Let's put it that way. Not too grey, not too dark.
Yeah, nice. Well, it's good to, yeah. I mean, as long as the weather's good on the weekend, that's the main thing.
That is the main
thanks
thing.
so much. Thanks so much for your talk today. I think it's great. It's always good to talk to people that are actually doing machine learning out in the wild, that are actually doing it with success. So, and just getting their best practices, what you've done, how you've sort of evolved your models and sort of improved things and sort of shown benefit. I guess that's the biggest difficulty in data, isn't it, is to actually prove that the thing that you're doing actually does have some business benefit in the end. And I think the way that you've sort of structured out the framework and taken us through that whole approach, was really cool. And I can see it's definitely no wonder you're really successful at what you do. So awesome. Thank you.
Oh, thanks, Peter. That's very, very kind. A lot of kind words. Thank you.
No worries at all. First up, we've got a question come through from Olga. I actually asked her, WNB. I'm just a simple old data engineer, so I'm just like, what the heck's that? But what sort of features or graphics you wish to have to monitor your experiments at WNB, but it doesn't have that? Does that question make sense?
Yeah, yes, it does. That's a great question, because I think Weights and Bias, they do have some good features in terms of like plotting the graph, whether it is like the metadata, and also you could block your the not just numerical data, but also kind of like images and audio as well. To be honest, I think the one thing that when I play around with it is I wouldn't say there's some missing features or graphics that I wish they have, but I couldn't find. One thing though, it is probably more on like if we want to plot the or from a monitoring perspective, if I plot all the, let's say, the system utilization, CPU, GPU, as well as the accuracy of the for each kind of inference, to compare the runs by all the runs, and for example, period, run all these inferences and then plot that graph. That is something that I'm not saying that it's missing, but it's something that I haven't found a solution for it. That I would say that's probably the only thing during my exploration with Weights and Bias.
Yeah, awesome. Claudia, one of our awesome co-organizers, she's said, great talk, Shin. I'd like to know what UI do you use for monitoring your ML models as well?
That's an interesting question. I probably need a little bit more elaboration on the UI, but I guess I could, use my educated guess for using monitoring for my ML models. I think in terms of like a UI, if it's from a model registry perspective on that end, for the UI, it's just like to show the metadata and the model and some of the the versions in that end. I think I probably wouldn't need a full-on UI feature. Yeah, it depends on what the UI it is for in terms of monitoring the ML models. And I guess, yeah, from a UI perspective, generally, probably, experiment tracking would be good, to have the, the graphs and be able to have a UI platform to see all the log metadata, as well as some kind of like a quick plot, and from a showing metadata. Yes. Yeah. So I guess in terms of the UI, I think I personally, I'm not a UI person, but I understand that there's benefits of UI. So yeah, in terms of my metadata, probably you just be able to show, all the metadata logged for each experiment run, or like the monitoring run, so that I could do a comparison. I guess comparison is the key thing in terms of UI, to be able to show, the trend, the progress, the kind of like the improvement between each runs and between, each monitoring, each inference during the monitoring. And in terms of like the graph side of things, I think to me it's good to kind of like be able to display some of the evaluation or analysis graph, but you could either do it on the UI platform or on a notebook or something. So yeah, so that's not probably not a critical point, at least in my opinion.
No, fair enough. Really cool. And just finally, like, so just on a similar topic, do you find, like when you're trying to sort of, I guess, show to the business how this model's going, and do you find yourself just pulling up a Tableau dashboard, or do you just kind of do a bit of exploratory analysis with, say, a Jupyter notebook with some graphics package or something like that, just to perhaps show to a business user, hey, I've been off working on this thing for a couple of weeks or months or something like that, and I guess this is the benefit that this machine learning model's brought, compared to perhaps doing nothing or something like that?
Yeah, so in terms of kind of like showing the benefit, I think there's like two use cases. to these categories. One, I would say, is more like on the real-time side, that I need to build an application with an embedded model and actually be able to show that this model work in an integrated system. So that's probably, it is more on like the application demo, whether it's a search engine, whether it is a processing system showing that end-to-end with like, some of the results down on like a front-end application. So that is something that is more like examples or like use cases, samples showing integrated into the system or application. On the other end, it's probably we call it like a batch, so it's like not real time, but more like on a schedule. It is kind of run in batch, and then the data, the output, essentially it is the product rather than the actual application. In that end, yeah, we found it kind of like definitely using the data and run evaluation on it and compare with the previous results, like before the model gets improved or before even using the model, and then to be able to show it side by side on like a dashboard or like a comparison graph that would give the business stakeholders a really good visualization in terms of like the benefit of the model.
Awesome. Well, we've got a ton of questions for you, but we'll have to leave it there. David Osler just chimed in and said, great presentation, Shin. I think we all agree with those sentiments. So thanks once again. And, looking forward to sort of hearing more from you in the future. I think as us data engineers sort of slowly grapple with, all that is to do with machine learning. So thanks so much, Shin. Appreciate it.
Thank you so much. Thank you for organizing it. So, yeah.
Cool. So our next speaker for today is Mercedes Speroni. She's another machine learning engineer. So it'll be great to hear from her. She's at MEQ Probe, the first Australian ag tech startup that combines ML and photonics to predict the quality of food. Prior to MEQ Probe, Mercedes worked for NASDAQ as a data scientist and Google in multiple technical roles, positively impacting more than 250,000 active users across the world in analytics products. That just sounds an incredible feat. So what she'll be taking us through is chain speed inference for computer vision pipelines. I guess that's kind of like supply chain related. So that is really cool. So without further ado, we will get Mercedes' talk underway.
Hello everyone, today I will be presenting a framework to reduce latency in machine learning pipelines that are typically deployed in factories. So first I'll give an introduction about computer vision and talk about the challenges of deploying computer vision pipelines into a factory setting, and I'll talk about the framework that I'm proposing to overcome those challenges. We'll go through an example of this framework, and finally I'll finish up with some conclusions. I am a machine learning engineer working for MEQ Probe. We are an Australian startup that works in the agricultural technology space. But before that, I used to work for NASDAQ and Google in multiple technical roles. Let's get started with a quick introduction to computer vision. So I specialize in computer vision, which is the field of computer science that focuses on building systems to extract information out of data. And the way we do that is in a very similar way to what humans do it, by looking at patterns. So in short, machines interpret images as a series of pixels, each with their own set of color values. So for example, we are looking at a picture of a very blurry Abraham Lincoln, where each pixel's brightness in this image is represented by a single 8-bit number. So it goes from 0, which is black, to 255, which is white. This data is then provided as the input to our computer vision algorithm that will be responsible for further analysis and decision making. Some of the common challenges that we face when we deploy systems into a factory some of them are very similar to what any data engineer faces when deploying systems into any type of environment. But on top of that, on top of the data and accuracy challenges, we also have space limitations, and we are, of course, not always able to mount the systems and we would like to. We also have usually poor bandwidth and reliable connectivity, and sometimes no internet at all. We have to ensure that our systems are product safe, that they are waterproof, that they are dust proof, they are compliant with the hygiene regulations. And finally, we also have to make sure that the predictions happen at the speed of the chain, otherwise they are pretty useless. So this is an example of a typical machine learning system that we would be building. In this case, we're talking about an object detection system that needs to classify and detect different types of food that go through a conveyor belt. And this has to be without relying on internet, and there has to be a prediction going back to the operator. So this is an example of how our system would look like. We have different types of product coming through the conveyor belt, and then we have our computer vision algorithm displaying the results and the confidence score back to the user interface. The challenge that I face with this is that there are not many frameworks for designing pipelines that comply with those requirements. So I did some research, and today I'd like to share the results from that investigation and propose a method for selecting different components and layers of this pipeline. So this is the framework proposed by the researchers from Cornell University in England. So they suggest that in manufacturing industries and in processing plants, there are 4 key data layers that every pipeline should have. And these are data source, raw data transmission, data communication, processing and analysis, and finally data visualization. But what I find is that, at least for our case, the 3rd layer has too many responsibilities. So I am proposing that it's better to decouple them and to also specifically add machine learning components to the process. So what I'm proposing is to have a separate machine learning service that contains a processing and a model inference data. So as an example of this, we can see that the graph explains the proposed design and the project constraints. So we're going to be building an end-to-end pipeline for object detection that is going to be streaming high-definition images. So the different components are shown in yellow in the right-hand side. So as we can see, the high-definition images from the connected cameras are uploaded or streamed to a local storage, which triggers the sending of the image metadata to a message broker. On top of that, a machine learning service pulls the works items from the queue and runs a prediction on those images. The prediction then gets shown in a user interface. As we can see, this visual inspection is a time-constrained process, and the time components are shown in gray. So the main challenge of this pipeline is to ensure that the prediction time for that object is less than the elapsed time before the next food item arrives in the conveyor belt. So in our case, this is generally around 1 or 1.5 seconds. Let's start with layer number 1, data source. And in this case, we define a data source in terms of its root source. So under our definition, a database is not a data source, but a data lake. In general, there are 4 main types of data source used in factories or in processing plants. Sensors are by far the most ubiquitous of all big data sources in the manufacturing industry. And this is not surprising because there are many different types and functions and uses for sensors. But also cameras have been used to capture images of products and on the production line. And then RFID and barcodes are basically printed labels that store information about an item, which is usually a product, to track its locations and state. And then 5%, I would say, of all the data sources are machine PLCs that are designed to receive signals from input devices such as sensors, and then use the inputs to control output devices such as switches. They can be considered mini computers that store data. Cool. So in our case, of course, we're going to be going with the cameras because we're building an object detection system. Layer number 2 is raw data transmission. So we define raw data transmission enablers as the technology that allows us to move the data from the source to the point in the pipeline where it's first exploited. So examples include IoT enabling microcontrollers, but also communication protocol software and hardware technologies that are used for harmonizing data that comes from different sources. And as well, we see some situations where some engineers decide to use removable storage devices for transferring data from a PLC or microcontroller to a computer that hosts big data software tools. We decide to go with wired connections to stream the data from the cameras to our NUC device. And it's important to note that the decisions that you make regarding the type of data transmission enabler that you're going to use are going to really affect the time that it takes for your pipeline to run. So for example, we decided to go for a 10 gigabit per second switch. So we are able to stream those images, maybe like 8 high definition images in less than 6 milliseconds. But if we would have gone for something like a cloud upload, that would probably take much longer. So we're talking about half of a second, maybe, the time that it would take to be uploaded into S3 bucket or something like that. So it's very important to know that the decisions in this step are going to really affect the time that your data pipeline takes to run. So in some cases, ingestion and communication tasks are handled by the same tool, but I think, I'm not saying this is ideal, but I think in general, what the industry prefers is a publish and subscribe communication model that has message compression. And we agree that this tool should be capable of both real-time and bulk data transfer. This is probably the best part of the conference, which is when we talk about machine learning. So as a machine learning engineer, I get very excited when I train a model, and I'm very happy with it. But then when it comes to deploying that model into the system, this is usually when I struggle with the data engineer, or I have some trouble. Sometimes the model that I deploy does not generate the same results as the trained one, or does not align with the system's requirements. So I'm going to go through some techniques that I found useful to overcome those challenges. And by the way, I like using TensorFlow, but I know that there are other technologies available for creating machine learning services as well. That should be good as well. This is probably the most common phrase used in machine learning, but it's good to start from the basics. Garbage in, garbage out. So this means that the quality of your model, your results are highly correlated to the quality of data that you receive. So I'm saying this because I think that having this in mind, we are able to also build better machine learning components and add some mechanisms to ensure that the data that we are receiving in real time in our deployed model has also maximum quality and is aligned with what we were expecting. And this is when data validation comes to play, because if we introduce data validation, we would be able to catch errors like blurry or noisy images, to spot if the image is in a wrong size, to see if the image is corrupted, to maybe alert if the cameras have been moved and now we are recording a different conveyor belt than the one that we were recording originally, or even if the data distribution has completely changed. So maybe we're seeing a lot of classes, a particular class has been increased in the data distribution. So this is also going to be a challenge for our machine learning model. But if we include data validation, we're going to be able to catch these errors and potentially even correct for them. So we can use image transformations like resizing, cropping, rescaling, adding a white balance, adding some color correction, including padding. And in this way, we're going to be able to ensure that the data that is fed into the model is high quality and is what we were expecting. But these transformations can be applied individually within a dataset object, which means that is we apply these transformations as a series of steps to a bunch of images, or also within the model, which means that we add a custom layer that applies all transformation as after the input layer, but before the machine learning calculations are actually done. So TensorFlow offers different options to be able to pre-process and convert these images into a machine learning format. Now I've done an experiment with 3 of these methods, and I think that the results are pretty self-explanatory. So we can see that there's a huge difference between some of them that are even like 6 times more efficient. And in my experience, the rule is usually that the hardest it is to code, the most efficient is going to be. For example, the 2 bottom methods require only 2 lines of coding, but creating a TF.dataset is probably around 25 to 30 lines of code, and it allows a lot more customization. For example, typically what happens when you're running transformation is that the accelerators sit idle while the CPU is applying the transformations to the image. But what you can do is you can include a prefetch option, and this would actually make your TF.dataset object run much faster as well. And then another question that I get asked quite often is if it's better to batch the data in a bunch of images, or if it's better to make predictions, to make an inference on every image at a time. So I think, of course, it really depends on the requirements of the project, but in my case, I find that large fetch sizes need more memory to store tensors, and I think everyone agrees with that, but they reduce the amount of communication needed between different operations. So overall, it reduces inference time to batch images. But there's a certain point at around a certain batch size when the runtime stops decreasing. So in my case, for this particular project, that number is 8, a batch size of 8, but really depends on the hardware that you're using. Finally, we're going to talk about model inference. So we look at 2 main performance metrics when we are thinking about the components for this layer, and those are inference time and other accuracy metrics. So inference time does not include the time that it takes for us to load the image, to decode the image, or to transform the image. It's the time that it takes for the algorithm to return a prediction. And remember that in object detection, we are trying to localize the object, but also to classify the object into the correct class. So in order to account for those 2 metrics, we look at MAP and IOU. So these are the most typical object detection metrics that we use to try to understand how accurate our results are. So IOU measures how much does a predicted box overlap with the true box, and mean average precision measures the area under the precision we call curve. So there's also something important to understand when we're using object detections, and this is why I think these are such important metrics that we need to consider when we are choosing the components for this service, is that different object detection algorithms have, of course, with different precisions, but at the same time, some of them take a lot longer to run a prediction. And this has to do with the way and the different methods the architectures are built. But that would be a completely new talk if we go deep into that. I just want to highlight that, there's always a big trade-off between a more accurate model and a faster inference time. So in this case, we can see that the fastest and the best model is YOLO. In this case, I'm using YOLO v4, but I'm also running YOLO using TensorRT to make it even faster than if it was running just using Darknet. And finally, moving on to our conclusion, we can say that the latency in the system pipeline is dominated by the model inference time and the data upload/data streaming. So these two components, the decisions that you make in those two components are going to play a huge impact in the time that it takes for the model for the whole pipeline to run. And specifically in object detections model, there's a clear trade-off between speed and accuracy, but we can also improve inference time by removing certain layers in the model, reducing the input size, or even doing changes to that model's architecture. And the data upload time can be reduced by compressing the images if you don't need to have such a high definition image, by running concurrent requests, by using maybe wire connections or a higher bandwidth. And I think that overall, what I want to say is I feel that there's a need for more machine learning specific data engineering pipelines, and hopefully we will address that challenge soon. Thank you very much.
Awesome. How's it going, Mercedes? Welcome to the live stream.
Good. Thank you very much. Thank you for organizing this. It's been really good so far. I'm enjoying the day.
Yeah, awesome. That's really cool to hear. I think I was chatting to you before on YouTube, and you mentioned that you're in Queenstown. Are you a snowboarder or a skier?
I'm a skier, but I tried snowboarding once, and I really, really liked it. It just seemed like wasted opportunity to keep trying something from the day one, because I have a little more experience in the ski. So I could see that it was gonna take longer to learn how to do something from scratch.
Yeah, absolutely. I'm a snowboarder myself, but I spend a lot of my time on the slopes on my backside, so I can appreciate why you took the easy path of sticking with what you know. Awesome. We've had some really good. You didn't come here to talk about snowboarding or anything, or skiing or anything like that. Fantastic talk. We've had some really cool questions come through on the chat. One from Sam Physics. Sorry. What do you think is more important, the data or the machine learning architecture in your end-to-end solution here?
This is a really interesting question, and I think it's been also quite recent in the data science space, where there's a lot of debate between where to invest time, if we should invest time on a more model-centric approach or on a more like data-centric approach. And overall, in my experience, the best results or the highest gains in accuracy have been from improving data. So to adding more pre-processing steps and ensuring that the data that you're gathering is high quality and is relevant to the problem that you're trying to solve. But I think there's a guy in the machine learning space that is called Andrew Ng. He used to work for Google, and now I think he's also doing some online courses, and he's really focusing on this data-centric approach for machine learning. And he highlights how he's done some studies, and he can prove that the biggest performance gains also come from improving the quality of your data and getting also better labeling tools and better labelings and better processes to ensure that the data that you're using is the highest quality.
Running a data engineering conference, that's really good to hear that data engineers are still have an important part to play. All jokes aside, but I guess it was interesting in your solution. You're capturing high definition images and stuff like that. sometimes in warehouses, and so internet connections and the speed of processing is a big deal. And so interesting, how you've spoken to, there's sorts of decisions that you need to, and the things that you need to think about, where you really shouldn't be using a cloud service in some instances, and deploying perhaps your model or your data processing a bit more closer to the actual device that's capturing the data.
Yes, that's true. We do use the cloud, but we do it afterwards to upload all the data to storage and to keep up with all the models versioning and all that stuff. And ideally, I think we want to move forward to using that. The problem is, I think that many industries, many factories don't have that availability yet, but hopefully that will be the next step in the industry, right?
Is it like using some sort of 5G based compute or something like that? They're talking about, but
yeah,
perhaps.
absolutely. And also, sometimes these factories are located in very remote places as well. So I think it's not only that they don't want to move forward; it's sometimes like very, very hard for them to make it available.
Yeah, it's just internet connections in remote locations in Australia. I think Simon O'Toole, our Thursday keynote speaker, is talking about astronomical data scale data pipelines, and a lot of where they're doing the data capture is in remote Western Australia, and so the NBN and things like that are very hard to come by. Claudia Silvers said, awesome presentation, Mercedes. Could you please explain what a ML-specific data eng that would be beneficial?
Yeah, well, I think that's maybe a little bit on context regarding my current role. So at the moment, we don't have any data engineer in the startup that I'm working on, but we do have a software engineer and myself. So I see it very clearly where it's just there's something in between our two roles where we could use some more data engineering best practices. For example, in the design of this whole pipeline, I feel that usually the way this is approached is by dividing. This person takes care of the graphical user interface and the back end of the system, and then I build the model and all the services related to that. But when you come to integrate them, there's a need to ensure consistency in these two different responsibilities. And I think that we could use some even in the tools. I think there's some limitation regarding the functionalities for machine learning, and something that Shin in the previous presentation mentioned as well. All the monitoring of different versions of the model that you deploy, all the different tags that you can add to your pipeline. Those are things that are emerging in the industry, but they haven't been there for a long time. So I think that there's a need to include more of these best practices, and just ensure that there's a better approach to sharing knowledge between machine learning engineers, data scientists, data engineers, software developers as well.
Yeah, perhaps in the metadata and tagging of models and data sets and things like that. That's really cool, and ties quite nicely into Keith's question. What's the current pipeline for retraining and monitoring model drift?
Good question. We do two things. First of all, we have a cloud pipeline that handles, as soon as the new data gets uploaded, it runs predictions and also monitors with some statistical analysis if the distribution of the classes have changed, or if there's something, if there's some outliers in those predictions that we were not expecting, and then that triggers an alert so we can actually review what's going on. And if the model needs retraining because there's a problem in the data drift, what we usually do is if, for example, if the reason of that data drift is because there's a new class that we are seeing coming in the conveyor belts that hasn't been labeled for, or what we didn't have enough examples for, we go and capture more data, we label it, and we retrain the model, and we deploy the new version and evaluate in some sort of data set that is representative of what we now are seeing.
So still a person in the middle of the process, but quite real time in terms of the alerts and notifications. That's really cool. Our final, going to squeeze in a final question, just because I'm a bit of a hardware geek myself. From Josh, you mentioned a NUC. What sort of edge hardware is needed for this sort of frame rate? Because HD images is quite high, isn't it?
Yeah. Yes, so we are using, like I mentioned before, an Intel NUC that has a GPU. So we think that is very important for the machine learning model to be able to process the high definition images in real time. We are currently running at I think it's like 20 something frames per second. So it's not like at the fast we could be running faster, but we also have to decide in terms of the size of the model that we want to use, the level of accuracy that we want to get. And these are all decisions that you make based on the requirements for the project. So if you need to deploy a very, very accurate system, you're going to have to make compromises in the speed and the rate. But if accuracy is not a priority and speed is more important than that, then you can go even faster than that by compressing the image, resizing, changing, using a different version of the model, specifically to be predicting for smaller image sizes and for smaller objects as well.
Yeah, all definitely considerations to do with latency and model performance, which I'm sure you've spent a lot of time evaluating. So that's awesome. I think Olga had some really great questions as well to ask you, but I don't think we've got time. We need a break for lunch. Thank you for sharing your wealth of wisdom with us today, Mercedes. Really appreciate it. And definitely go enjoy the snow while you can. That's sounds like it's an awesome location to be living in at the moment. And we'll thanks once again.
Thank you very much. Have a good one.
Cheers. Thanks, Mercedes. Awesome. We're just going to have a quick break, half an hour, grab some food, and recharge the batteries, and then we'll be back shortly with the startup panel, which is going to be some very lively debate, I'm sure. Definitely stay tuned for that. But definitely be sure to grab a sandwich or something like that, and maybe just say hi in one of the hallway track channels or something like that on Slack. See you all shortly. Thanks. Bye.
Good afternoon, everybody. Good to have you back. Welcome, everybody, to this afternoon session. How good was our morning session? For those who don't know me, my name is Ingrid Ansola. I'm the head of platform Chipit. I'm joining you from Sydney, Australia, and I will be joining Peter today during the afternoon to show you our amazing lineup. Thank you to our morning speakers, Mac, Stephen, Mercedes, and Shing. It was a great start of the conference today. How good they were, right? Well, we had a great lineup for this afternoon as well. We are going to start with Simon Aubrey will be hosting our startup panel, where James Weekly, Vishal Rizal, Jess Flanagan, and myself will be talking about building data teams within startups. So please don't miss it. Then we will have Dean Nguyen talking about trust, knowledge, and your data, our approach at CADA to building a great data product. Then we will have Harmeet Sokhi. She will be talking about chief left testing, building reliable data pipelines. And to close the day, we will have Chris Benson talking about beginner's guide to Azure MLOps. So that's looking really good today. Before we move forward, let's say thank you to our great sponsors who make really possible this conference to be as good as it is. Snowflake, Fivetran, Databricks, Microsoft Azure, Amazon Web Service, Imply, Versor, DBT Labs, ThoughtWorks, HighTouch, Microsoft Reactor, Yao Conference, and Cloud Shuttle. Thank you again. Before we move forward, I want to remind you that if you want to engage with our speakers after their talks, you can ask questions in our YouTube chat where you are watching us right now, or you can join the conversation on Slack, and we will make sure those questions are answered by the speakers. Please remember our code of conduct. We respect the community around us at all times. Be a good online citizen, and please, I ask everybody to conduct themselves very nicely and friendly today. Without more delays, let's start with our startup panel, and I'm going to be introducing our awesome host today, Simon. Hi, Simon, how are you?
I'm doing really well, and thanks for the warm introduction, Ingrid. I think it's been an absolute fantastic conference so far, and I have the wonderful pleasure of introducing this fine panel, essentially representing the data engineering interests across our startup community. So very briefly, my name is Simon Aubrey. I'm a principal data engineer joining you from ThoughtWorks, and I'm based out of Sydney in Australia. But you won't really be hearing from me. Today, you're going to be hearing from an amazing collection of fine startup folk. Now, many businesses offer a unique opportunity to learn and influence and build out a data engineering culture, but startups are unique. Not every startup is going to be the same. And today we have a fantastic panel that represents essentially the spectrum of startups, from first hire through to funding, and some of the opportunities and some of the challenges when we're talking about scaling and growth. And we're not just here to talk about the stereotypes that we might see in shows such as Silicon Valley. We really want to find out what it means to be part of and driving out both the culture and the capabilities across startups. So I'm really excited to meet and welcome our panel today. So I'm going to ask each of our four panelists to briefly introduce themselves. So I'm going to ask each panelist in turn just to introduce themselves, maybe give us just a tweet-sized introduction about your company, what your company does, and where you see some of the challenges around data and data engineering. So firstly, I'm going to ask James Weekly to introduce himself.
Hi, Simon. Thanks for the warm intro. Very happy to be here, and I'll do my best not to be a Silicon Valley stereotype. I've just started watching that show. I'm a little late to the party, but it's quite funny. So yeah, I've worked as a software engineer for most of my career. I guess I could call myself a data engineer as well, or a data architect more recently. But now a startup founder as of about a year ago. So Omnada's mission, I guess a tweet-sized summary of that would be that we're taking third-party middleware out of data integration for the cloud. So Maxime spoke earlier about data infrastructure services, this big ecosystem of cloud products. We are definitely one of those, but in our case, our products complement the infrastructure that you already have rather than adding more into the mix.
Oh, thanks so much for that, James. And our next panelist is Jess Flanagan. Jess, would you like to introduce yourself? Jess, I have to say it, you're on mute.
It had to do it. Someone had to do it. So yeah, I'm Jess Flanagan. I'm a co-founder and head of engineering at Deckard Technologies. At Deckard, we take mostly real estate data and we analyze it and give actionable insights for cities and counties. So helping with things like enforcement of permit rules and short-term rental registration systems and that type of thing. So we take large amounts of data and give local government insights so that they can, have a fairer and safer system, and that's mostly for the US. So in Simon's sort of worldview, I'd describe us as Silicon Valley meets parks and recreation would probably be where we fit.
Oh, fantastic. It's so good to welcome you, Jess, and I appreciate the orientation using American shows. That's very helpful. Now, we've already heard briefly from Ingrid, but I'd like Ingrid Azola to introduce herself and tell us a bit about ShipIt.
Thank you, Simon. As I said, I'm Ingrid Sola. I'm the head of data platform at ShipIt Australia. And ShipIt is a tech company that works with to support your logistic business. So as you know, our logistic business has gone through quite some transformation in the last 18 months. So we have a few challenges within data engineering, and mostly it's about, serving our customers as much as we can instant data in the logistics business. This is key and important, and we are building a very reliable and strong team within ShipIt. So looking forward to this conversation today.
And we're really interested to find out a bit more about your space, Ingrid. And our fourth panelist, can I get Bishal Rizal to introduce himself?
Thanks, Simon, and hello, everyone. I'm Bishal, and I'm leading the data engineering efforts at Lumi Finance currently. We launched about 3 to 4 years ago, trying to solve a problem in Australia where it's just incredibly difficult for SMEs to get access to capital. It's a complete market that the banks really fail to cater to. And what that means is that SMEs basically look to smaller lenders like ourselves whenever they have capital requirements. We basically differentiate ourselves by taking a completely data-driven approach to lending. So we've built a proprietary system where we handle everything from the origination side through to the credit underwriting process and also the actual servicing of the loans. Obviously collecting a lot of data through that entire process, and that's basically the way we make all decisions, whether it be for a specific customer or the wider business / product.
Oh, that's absolutely awesome. I'm so excited to have you all here. James, Jess, Ingrid, Bishal, you all represent different industries and different levels of maturity in the startup and scale-up industry. So I might pass my first question over to James. James, you're essentially the first hire of your data company. Do you want to give us a bit of a sense about like your thought process, the tasks, and your to-do list ahead of you, and maybe also give us a bit of an idea about how you carve up your time to deliver value to your new business? Thanks,
Simon. Omnada is actually the second startup that I've worked for, in the sense that I was there on day one. And I think what the initial roadmap looks like depends a lot on the nature of the startup. So if it's one that has a very certain future, right at the start, like it's maybe a spin-off of an existing company, or it's just got some immediate revenue stream to tap into, then in that situation, I would normally be more strategic with getting things in place, platforms in place, getting operational needs up and running. Whereas if the company has a more limited funding horizon and maybe it's just trying to prove that it's viable, then I'm much more in favor of a minimalist approach, especially given that most startups fail, as we know. So you want to dedicate yourself entirely to helping land those early sales, and just give yourself permission to use spreadsheets and incur a bit of tech debt if you like. Tech debt's not a bad thing if you know that you're incurring it, if it's deliberate. And also, I think it's not likely to be glamorous work either. Getting a company up and running involves just a ton of mundane things that are really important that we usually take for granted in more established companies. So like I said, I've been in both situations and I've both approached it differently both times. Unless your startup is like Descartes, where Jess is, where it's an analytics product right on day one, you're probably more likely in that first category where you've been asked to get things established and you're not in survival mode, you're in kind of build mode. So in that situation, you're sort of doing two things. You're being like a chief data officer and meeting with your stakeholders, but then you're also being an engineer and you're getting some infrastructure in place. One last point that I'd make on the infrastructure side is the same advice I'd give before becoming a vendor. It looks really biased now that I am a vendor, but I've always thought this way, which is that you want to outsource as much as you can. Again, back to Maxime's talk, most organizations tend to spend more than they need to on people and less than they could on software. So I think, this is where I think for the most part, it's because people tend to measure importance by headcount still in most organizations. So this is where meeting with those stakeholders helps because they can see that they know why you're investing in what areas. And of course, you still need to build a team, but it's got to be for the right reasons. And I think if you've got a whole team of data engineers that don't really know what your company does or what its products are, then you might be over-focused on infrastructure. So that's my little bit of starting advice.
Oh, that's fantastic. And I guess we can all appreciate the trade-off between build versus buy, but I might just broaden it out to the panel. Where do you see that trade-off? James spoke about some of that being sort of a bit of a fixation on scaling team numbers because it sounds impressive. But I was wondering what thought process you have and what considerations there are when it comes to buy versus build.
Yeah, I completely echo everything James just mentioned. I think as data practitioners at smaller companies, we need to understand where we can really provide value for reaching the wider business strategy. So it's just important to have alignment between the data team and the wider business. To be honest, if we're trying to solve problems that another tool off the shelf can already solve for us, it's probably not a good use of our time because our expertise lies in our contextual understanding of the business and its growth. So I think it's a balancing act between paying for expensive SaaS tools to do the job for us or hiring more staff to do that same thing. I think another thing that often is not considered, that needs to be considered when doing that as well, is the maintenance costs as well. So if we're building these new tools from scratch, what happens when they go down? How do we recover from disaster? All of those things, because again, that's taking time away from where we could be providing real value.
For us, there's also an element of how close to our core competencies is it? Because if we're going to have to do similar things in the future and the off-the-shelf tool is going to give us a sort of a 70% coverage, if it's in our core business, then we may still build it ourselves because we need that, that might be what gives us an advantage. And for us, in some cases, we've had a better way of doing something and that gives us a competitive advantage we might build. But that's, a very rare decision. Most of the time, if I can slot something, number one, I check if I can get something open source. Number two, I start checking, if we're already in an AWS infrastructure, if I can just pull something in off the console. And then after that, I start looking at other tools. And only as an additional step do I start, commissioning teams to build things.
Yeah, I couldn't agree more. And I think that something that is important to point out is that not because you decide today to use an off-the-shelf tool doesn't mean that your architecture cannot evolve and maybe sometimes reuse implementations that have a different purpose within the business. So I think that you can start with an off-the-shelf tool. And if you plan your data strategy, our data strategies are usually 12, 18 months vision. So you always can plan ahead and decide when do you want to start moving away from that off-shelf tool. That's a viable solution as well.
Oh, that's awesome. I think that guidance from all of you is super helpful, and that probably works for both startups and considerations for enterprises. I was wondering if we can maybe make this a bit more specific around startups. And I actually want you to get a bit of an understanding around funding cycles. So maybe my understanding from watching Parks and Recreation and Silicon Valley isn't 100% accurate. So I might ask Jess, many startups evidently are going to need a level of injection for funding. How do you build up that rapport, or what kind of insights do you need to report and satisfy some of the metrics to keep your venture capitalists happy?
So for us, there's probably two kinds of metrics. One I stay completely out of, and that's our CFO's problem. So I don't get involved in tracking our spend beyond our AWS spend and my team's headcount. So leaving that aside, the actual metrics about how big we think the market is, how much headcount it would cost to support as we grow. So we sell our product into either cities or counties. And so it's one thing, it costs this much to support the first city. And if it cost us that much to support every city, we'd go bankrupt. Because, the first time you do something, it's a lot more expensive than as you build it for everyone else. So we had to produce a lot of metrics to say what we thought that would project out as. And while venture capitalists were asking for it, we needed it in-house anyway. And if you're building high performance teams, that's the kind of thing you have to do. You have to be tracking how effective people are, because otherwise you'll quickly find that adding more engineers, it's not necessarily going to linearly scale your productivity, but it also shouldn't stagnate. So we haven't been asked for any huge amounts of data from our venture capital that wasn't valuable for us to know anyway. And that's probably how it sort of played out for us. Is if we've been asked a surprise question and we've had to generate the data, we've realized we probably should have been generating that.
Yeah, that's terrific advice. And I guess I'm interested on where that leads up to, which is essentially hiring and what it looks like when your startup actually gets a level of money. So maybe I'll ask Ingrid, what does it look like when you actually get to that nirvana point where you actually do get a level of fund and a level of capability around your ability to hire? If you could take us through what that sort of business case looks like and that sort of heart-stopping moment of moving forwards and actually hiring and growing the team.
Yeah, thank you, Simon. Yeah, I think that relates a lot with what actually Max was talking about this morning during the presentation. Like, we need to be able to communicate the complexity that is around creating data strategies in the business. Is as complex as, the software engineering and other strategies around the business. So I think that the business case has to be around a holistic strategy. Separate your initiatives very well. So talk about security, about data quality, about obviously governance, and about analytics. Because sometimes we tend to think of data analytics, but in reality, analytics is is one of the many areas of the data ecosystem that you are trying to build into the company. So I think that if you separate those initiatives and create a holistic strategy around it, that's how you build your business case. I think it's important as well that you include cost. Talking about the cost and the impact value that building the data team is going to have to the company is very important. And I think I would say start small. Start creating is what we usually call low-hanging fruits. I don't think there is anything wrong about approaching those low-hanging fruits and starting, creating, deliver value quickly to the business, because that's how your team can actually grow and scale. So I would say create an MVP and start from there. Like create your MVP and then create a strategy of that, how MVP is gonna grow over time. Does that answer your question, Sam?
Oh, absolutely. And I'm interested almost in that moment of the first hire. We heard from James earlier before, where obviously he was maybe a slightly bit biased around his choice for his first hire. But I was wondering, maybe from yourself, Ingrid, and maybe then I'll ask all of the panel, who was your first hire, and what was your thought process in prioritizing like the capabilities or the characteristic around that first hire and that sort of first team structure, what that actually looked like?
That's a very good question, and obviously there is no one size fits all kind of answer. We have one pattern I have seen in recent years is we go from right to left. So companies start building the data analyst team and the business operations, create a bit of, let's say, technical depth in the infrastructure that in the data pipelines, and then data engineers are introduced later. The problem I see with this approach is that creates a bit of friction, because data engineers start to have competing priorities between addressing that tech debt that was created from early on versus starting adding value, tangible value to the business that, as I mentioned before, is very key to be able to grow your team, to build your business case. So that approach, right to left, even when it's a pattern that we have seen, I'm a bit tempted to say it wouldn't be my go-to option. I probably will start with analyst engineer or a data engineer from earlier than usual. So we can start probably, not just, I'm not saying that we won't generate technical debt, but the data engineer can own it and create a roadmap to address those, quickly wins that sometimes need to be refactored or restructured later.
Oh, that's awesome. And it's terrific to kind of think about what that sort of early stage looks like for a startup company. But I'm also interested in the scale up point. Essentially, when you're in this wonderful situation of building on the successes of your past and actually talking about scaling your data team going forwards. So I might shoot a question over to Bashal. So many startups obviously go through this transition of becoming sort of bigger, and maybe some of the considerations that got you going aren't some of the considerations that move you forward. And maybe that sort of can-do attitude that sort of gets you from scrappy to something maybe isn't the mindset to take you forwards. So I was wondering, Bashal, what are some of the key considerations when you're thinking about maturing a data team?
Yeah, there's obviously a lot to unpack there. I think a little bit of background would be good, maybe about Lumi's journey. So we initially started with no data team at all, a software engineering team that acted as like a pseudo data team, and we're obviously in the finance space. So we have a lot of requirements around reporting, whether it be for investors and funders, both debt and equity, but also around regulation and things like that. So yeah, it's been an interesting journey. I think the most important things that we did in order to keep the ball rolling and allow us to kind of grow leaps and bounds within months, let alone years, has been alignment across our team and the wider business. Initially, when you're 5 to 6 people, maybe working out of a library or a living room, it's very easy to do. But once your team becomes a lot bigger and a lot more decentralized, it's really important to make sure that your data team is aligned with what the business is trying to achieve as well. I think one of the big things that change after you start to grow your team is you get some subject matter experts, and I think they're probably the most valuable resource to the team. For instance, I'm working in a fintech, and obviously I probably have more financial understanding than the average data engineer, but that is nothing in comparison to someone who actually works in finance and is actually dealing with these things day to day. So I think knowing like and accepting that your data team isn't going to be an expert in every single field and everything that you need to do, but knowing how to source that information and really working with all these business functions to achieve the goals is super important. I think that's also a key way to structure your data team as well. We really focused on hiring, like I guess you could give them the title of like business analysts or data analysts. But with the tooling and resources available these days, they very much act as engineers. Maybe they don't have the foundational understanding of a data engineer, but they're really able to even design data models and really power their BI use cases and their reporting use cases, basically self-service. What that means, though, is that the data engineering team and the data platform team really need to start considering things like governance and security and permissioning, especially when you're growing and if you're in a field like ourselves, which is finance, where there's a lot of PII data, really restricting access and making sure the right people are still able to do their jobs where required, but trying to limit it as much as possible is super important. But yeah, I think those are probably the main things to consider when we're growing a team. Obviously, there's a lot of resources and tooling available. Another thing is probably the shift from like a really reactive approach to your data engineering to more of a proactive approach. I think in those early phases, you're already in debt when you receive your requirements. It's something that you should have solved a few months ago. But as you start to get more tooling and resources and manpower behind your team, you can really start to consider things that are maybe 6, 12, 18 months down the track and making sure that your solutions, your decisions are catering to those as well.
Yeah, that makes perfect sense. And yeah, really like that sort of idea of Vishal that you're presenting around, sometimes the maturing around, certainly in financial services, you've obviously got to adhere to those those guardrails and some of those compliance concerns. And again, I feel I've been undereducated by watching Silicon Valley because data governance and lineage has never come up as a plot point to the best of my knowledge. So I might turn this into a bit more of a sort of a lightning round and ask for almost like your crystal ball or at least considerations of where you think data engineering is going to go in the near term, and maybe your opinions around what the tools look like or what some of the techniques look like, or what just sort of interests you between now and 2022. So I might just do a bit of a lightning round because I'm really interested in getting your opinion about what we as data professionals should be keeping an eye on. I might ask James to kick off the conversation.
Well, obviously, I'm going to say Omnada is a tool you should be keeping an eye on. We've got some new features coming, but also some brand new stuff coming early next year, which I'm really excited about. But outside of our sphere, I think I'm really interested to watch the gap between batch and real time beginning to blur. Tools like Materialize and a bunch of others, Rockset, that are kind of this, making it not such a big choice in terms of how fresh your data is. That's really exciting and very new. And I think the other one we've already seen that's going to continue is just big data platforms, the likes of Snowflake and others, that will find their way more and more into production systems, like for typical companies, like not just massive tech companies, but normal non-tech giant companies will be using these platforms a lot more in day-to-day production than they used to.
Yeah, makes sense. Maybe I'll ask the same question to Jess. What tools are you keeping an eye on, be them like tools or SaaS products or practices that have your interest for 2022?
So I won't name any specific brands because I'm still shopping around, but I'm very interested in tools that help with managing metadata and data lineage, tools that better help with testing in the data engineering space, and tools that give you better visualizations as to what's going on in your ETL pipelines and being able to monitor the quality of the data that passes through them. Because some of that stuff is stuff that we've, custom built some things, and some of the stuff we've used other off-the-shelf tools in ways that they weren't really designed to use. And I haven't gotten a good solution for all of those in our stack right now, which is just partly due to probably the fact that we've spent the last 12 months moving too quickly to have a good stock take there. But that's where I want to do a stock take over the next year.
Yeah, that makes perfect sense. And Ingrid, is there any sort of tools that you're particularly excited about, or what's on your wish list for 2022?
Well, I'm always keeping my eye on the great changes that Snowflake, is adding to its a platform is something that I'm always keeping my eye on. Obviously, data sharing is something that I think is going to take an interesting direction in the short term. I'm keeping my eye on DataEngBytes as well. I haven't used it personally, but I find it quite interesting. I think that roller stack is actually surprising as well. And from visualization, I'm actually would like to see Clipfolio to be embedded more often. But that's more a wish that, I think that they're doing very well. So that's where I'm keeping my radar.
Oh, absolutely. And closing out the question, Bashar, what's got your level of interest peaked?
Yeah, I think the battle between all of the cloud data warehouses, including Delta Lake, which is Databricks' offering, they all have pros and cons of each other, and I think right now they're really trying to differentiate themselves from one another. So it'll be interesting to see what approaches they take. I think from like an ideology point of view, like the data engineer kind of acting more as like building a wider data platform and trying to build more of a self-service culture in most product-driven businesses. I think there's a lot of tooling right now where a lot of data requests can probably be handled without data engineering input. So I think that self-service is going to be a big thing that starts to become more popular in the future. And I'd say the other one is the battle of the orchestration tools as well. I think Airflow, Prefect, Dagster, they all have pros and cons again. So and they've all got big communities and are being updated very frequently. So it'd be interesting to see how they try to differentiate themselves from one another as well.
Yeah, that makes perfect sense. And absolutely that theme around what does an analytics engineering mindset actually mean in reality. That's such a divisive conversation. And I always like this. I think if you ask 10 data engineers what the future would look like, you'd end up with 12 opinions.
Yeah.
But I'm also quite interested in like just this sort of avalanche of open source tools. We've in this sort of wonderful space where there's many ways to solve any challenge. And to your point earlier, Bashar, even something as straightforward as orchestration, it's not a default answer to just say Airflow anymore. It's actually a really solid consideration for any new or growing or evolving team to either pick the most relevant tool and potentially sometimes reflect on the tools that got them to a particular point maybe aren't the tools that are going to move them forwards. So this has been a really, really great conversation. I wish we had more time, but I'm conscious that we've only got 5 minutes. So I'm just going to ask sort of just a closing out question around what you think is a top of mind consideration from your own space. Or failing that, I'm going to ask you the question that I always get asked when I get to chat to startup companies is, how big does your company need to be to hire their first data scientist, their first data engineer? And it's again, one of these sort of polarizing moments of how big do you need to be to get to that next domain specific role? So Ingrid, I'm going to ask you first. What's your opinion?
Look, to be honest, I will drive my decision more about where the state of the data is than the size of the company. When you find yourself looking for those third-party tools to do, usually starts with let me do a batch processing because I need some visualizations. When you find yourself in that point, then I would say that's the time when you probably need to start the conversation with data engineers and bring them into the before your infrastructure gets too big without proper direction or strategy. Data scientists, I don't feel equipped to take that decision without, inputs from the rest of the team. I think that that's definitely very variable, and I don't feel comfortable saying like this is the right point to bring data scientists, because there is a lot of dependency from the state of the product, to be honest.
So James, without disclosing too much, what's your thought process around the trigger points in an organization for hiring the next engineer or the first data scientist?
Yeah, I have to give one of those annoying "it depends" answers, Simon, because if there was a right answer, then you probably wouldn't get asked it all the time. I guess that the answer I think of is, you have to be big enough in revenue that they can pay for themselves somehow. So the incremental value they deliver has to be more than you pay them, of course. And you have to have enough cash in the bank to be able to hire them in the first place and get them up and running. So that could be on day one. It could be on day never, depending on, the revenue model of your business. So it's probably the most annoying answer you'll get from the panel, but that's all I got.
It makes sense. What about you, Jess? What's your thought process?
Well, we sort of cheated that one there because we're co-founded by both a data engineer and a data scientist. So we had them from the ground running, which makes sense because our company is a data as a service offering. So in which case you really you want that expertise immediately. From there, I think most startups probably want to hire a data engineer quite early on to be having those concepts going through. But no one at a startup has one role. Everyone has to do. I've spent enough of my time running payroll to know that my role isn't limited to data engineering. So you may not hire a pure data engineer early on, but you're certainly going to want to hire, the first time you hire a software engineer, you're going to want someone who either has a strong interest in data or some type of background in data, so that they're building those efficiencies in early on.
No, it makes perfect sense. And Bashal, do you have a thought process or an opinion around how big is big enough?
Yeah, it's an interesting one. Again, as I said earlier, we launched with a software engineering team. So yeah, I was a core contributor to the software platform, building front end. I don't know who let me do front end, but the front end aspect, but also the server side. I guess I kind of, as I said earlier, the data engineering workloads were kind of spread amongst the software engineering team. But I think you start to get to the stage where it just really requires direction. It requires someone to kind of take charge and ownership of that, and kind of understand how to combine that with the business's future. So I think that's kind of the approach that we took at Lumi. It was like kind of shared amongst the team, but then slowly we made a decision that, kind of echoing what James said, it kind of makes sense for the business to have a full-time dedicated resource to just building the data side. So yeah, that's kind of where our data engineering team spun off. So I don't think there's like a requirements list that you need to tick off. It's more, as a startup, you're probably going to start doing some sort of data engineering work before your team exists, unless like you're in a situation similar to what Jess is in. And then from a, like, whether it be a tech debt point of view, you don't want to, or like just a direction point of view, or hey, the data is actually starting to provide tangible value to the business point of view. That's kind of when the data engineer probably gets a title versus just generalist.
Oh, that's fantastic. I would love to continue this conversation, but unfortunately we're at time. So all I can do is say thank you. I really appreciate Bashal, James, Jess, and Ingrid for your honesty, how much you've shared today. And I know on behalf of the data engineering community, really enjoyed the conversation today. So thank you so much, and really look forward to both seeing your companies grow and your success going forwards. Thanks so much for your time this afternoon.
Thank you.
Thanks, Simon.
Thank you.
Awesome. Well, thanks so much, Simon, for hosting that startup panel. I think it was, really, really cool to learn from all the wonderful sort of data engineers that we have in the communities working in the startup ecosystem. Thanks to you, Ingrid. That was awesome hearing your insights. So,
thank you.
Really cool. So up next, we have a speaker that has experience building data products and is doing a data engineering startup in the metadata and data lineage space. His name is Dean Nguyen. He's the CEO and co-founder of Carta. It's a Sydney-based data startup. They're building a data knowledge platform that helps organizations scale their trust and knowledge in data. Prior to Carta, Dean was the CPO of or Chief Product Officer for data at Macquarie Bank. So he's got a really interesting background. Very much looking forward to it. One second, and take it away, Dean.
If working in data has taught me anything, it's how to fail, because you do it a lot. Hi everyone, my name is Dean and I'm the CEO of Carta, a data startup based in Sydney. We build K, a data knowledge platform for organizations to understand, govern, and scale how their data products are used. It's part data discovery, observability, and knowledge management. And it's the next evolution in data catalog and governance tools. In our journey, we've analyzed thousands of data products and found that 95% of them fail. That's right, 95%. Most data products, whether it's a dashboard, a model, an app, or an API, barely get used, and they die out within days to weeks. It's really sad to think about all the effort that goes into building a data product, the pipelines, the engineering effort, to see it all go to waste. And it's not just a once-off cost either. When it makes it to production, you may end up having to support it despite the fact that it's dead. It reminds me of this one story where we worked all night fixing this failed ETL job that was loading this app. And when we told the business the next day that it was all fixed, they said, "Thanks, but we haven't used it in months. In fact, we weren't planning on using it at all." It was one of those truly head-shaking moments. The good news is that there are data products that do deliver value over a long period of time. And when we take a deeper look into these products, they have a number of characteristics that make them successful. The first characteristic is that successful data products are ones that are really well known. In data, we spend a lot of time designing and building products, but not a lot of time in promoting them or selling them. Data ecosystems can be really complex, and it's hard to get people to pay attention to the latest and greatest data product that you launch. It's why there are so many duplicates of this and that. I remember when we were decommissioning a data warehouse that we had found all these users that were using these really old data sets that had been replaced ages ago. And when we asked them why they hadn't migrated across, they said that no one had told them. They had no idea they'd been replaced. And this is pretty common in a complex data ecosystem where data products can literally die because users don't even know about them. They don't even know they exist. The second characteristic is that successful data products are ones that are trusted. They almost become famous, part of the business. People just know that if you're trying to solve this problem, you need this data product. Trust, unfortunately, is not something that is easy to engineer into a data product. It's developed by your users, and they take different signals to determine their level of trust. It can be social signals like who uses it, how frequently, for what use case, to technical signals like freshness and lineage. Data products that are unsuccessful are ones where users don't trust them. They don't trust them over other data products, maybe even ones that they create themselves. The third characteristic is that successful data products are ones that people know how to use. It's either really easy to pick up, or the knowledge is easy to consume and build over time. It can take the form of comments in code to API specs, data dictionaries, or training guides. Successful products are ones that tend to have their knowledge constantly being updated, while dead products are ones where there is stale knowledge or no knowledge at all. These three elements were, among a few others, the key differences to the success and longevity of many data products we assessed. It was also the three that was not usually included in the way that data products are built. But we need to. And it's important as data engineers, data analysts, data managers, that we think about the way that users will learn about, have trust, and learn how to use our products. So I want to share 5 practices today that you can use to help build awareness, build trust, and build knowledge. They are building an audience, defining the purpose, scaling knowledge, getting feedback, and tracking metrics. And as I talk about these practices, I'm going to show you a little bit how we solve this in our own product. But I do want to say you don't need to use our product to do this. Implement these practices however you can, and it will make a big difference to the longevity and success of your data products. The first practice is building your audience. Define who needs to know about your data product and how you are going to engage them. When you launch your data product, don't just publish it, throw it out into the ether and hope for the best. You need to engage, sell, and remind users that your product exists and it's here to solve their problem. The way we do this in K is to use a recommendation engine to push product news like launches and changes to people that need to know. Kind of like a Twitter feed for data. Our engine tracks what people use and follow so that news and reminders are relevant and timely. And if you want to do this manually, I would start with curating distribution lists based on domains or topics and using that to drive engagement. And I think this is why some data catalogs have failed in the past, because they've been based around search, which means your users need to sort of know your product exists in order to find it. But that's not true in most cases. Users don't necessarily know, and so you have to take on the job of pushing that to them. The second practice is defining the purpose and making sure that your users know what your product can be used for. It's really surprising to see how poorly defined so many data products are in the organization. Why was it built? Who should use it? What for? It may be that it was defined early in the life of the product, but it very quickly evolves over time. And that's where a lot of users lose trust in the data product. It's when they try to use it and it doesn't work. And it's not because the product is wrong, it's because the use case they tried to use it for is not what it was built for. So define these boundaries of your data product. It will also address issues like data leakage or unnecessary data exposure. In K, what we do is we label all of our data products, whether it's a dashboard, a report, an API, with what their verified use case is for. And it even influences our trust score, which helps to drive users to products that can be trusted for a specific purpose. The third practice is scaling knowledge. Knowledge is something that needs to be kept up to date and it needs to be accessible. There is knowledge that you can automatically capture, like who uses it, to what does it join to how it's created, and how others have used it. And then there's knowledge that you have to curate, like context that people can add. It might be business logic that you add to your code, or descriptions that you might add to your data, or you might pull in from your DBT models, or answers that you give to your frequently asked questions. Whatever that knowledge may be, I'd recommend that you keep it in a single place that can be linked to your data product. This makes it easy to find, easy to manage, and easier to automate as much as you can. You need to reduce the friction between your users and your knowledge base so that they can learn how to use your product as quickly as possible. The fourth practice is to get regular feedback. If you haven't heard it from a product manager yet, then feedback is one of the most important things that you can use to help make your product successful. So many products we have seen get launched and you never get feedback for them. Feedback gives you a chance to save a dead product. It also can make your successful products more successful over time. In K, we use feedback loops to capture sentiment at the time of usage. We also use feedback loops to close knowledge and governance gaps as well. Feedback is one of the most critical steps that you can take, that you can use to make your product successful. The fifth and final practice is tracking metrics. Every data product needs to have a metric that you can use to tell whether or not it's going well or it's going poorly. It may be a simple metric like weekly active users or total usage over a month, or however many decisions were made off this data set. They don't have to be complicated. At a minimum, I recommend tracking usage because data that's not being used is not generating any value. Imagine a churn report being used by the retention team to call customers every day. That's a really valuable product. But if we see a drop-off in usage, it gives us a signal that maybe users don't trust this data for a particular reason, or they've stopped using it. So that's 5 practices you can use to make your data products more successful. Building an audience, defining the purpose, scaling knowledge, getting feedback, and tracking metrics. Our customers and partners who have adopted these practices are seeing their data products grow faster and with greater user satisfaction and trust. And that's the message I want to leave you with today. The value of your data product is proportional to the shared awareness, trust, and knowledge you can build around it. I hope that you take some of these ideas on board, and I'd love to hear how you go. Please reach out to share your thoughts, and if you want to learn more about our product. Thanks for listening, and stay safe.
Thank you,
Awesome.
Dean. That
Welcome,
was
Dean.
awesome.
Hi everyone. Thanks for that. It was a lot of fun recording it, especially once you get to editing all the memes and GIFs in.
Yeah, I mean, hey Ingrid, we love a good meme at the DataEng meetup and comp or whatever. Yeah.
Yes, definitely. Yeah, very, very interesting, Dean. Like everything about data product. I'm curious. What's your view on how to structure? You talk about the feedback loop, and I'm curious, how do you structure that feedback, and how do you how it drives your decisions around the data?
Yeah, I think the way we sort of see feedback loops is that there are different audiences to get feedback from. And it sort of changes sort of industry to industry or business to business. I think there is a lot of value in collecting feedback from your end users, so your consumers. And really the type of feedback that you want to get from them is things like, what are they actually doing with the data? What decisions are they driving with it? What outcome were they expecting, and what outcome did they actually achieve? And that's really important because that then ties value back to the actual data itself. There are other feedback loops that you can build around sort of your users of data. So it might be your data engineers or your data analysts. And what you actually want to collect from them is not necessarily feedback around, how the data was used, but more about the quality of data. What's missing in it. How could it be improved? Those sort of things.
Thank you. Yeah, yeah. It's very interesting. We have loving the example of the venture worked.
Yeah, unfortunately, we can't use our customers' data for the demo.
Simon O'Toole said discoverability is hard. We, the astronomy community, have been working on this issue for about 20 years with some success, but we're a small field. I think Suprabhat Sinha, he said 100% correct. It's tough, but it's something to be answered beforehand. So lots of really good comments coming through. I think Simon Waite chimed in again. If you're making decisions in the absence of metrics,
Definitely.
you're just guessing or deciding biased gut feel. So yeah, all really, really great points that you've come through. Did you feel that coming from a data product manager background at Macquarie Bank, did that help you in your journey, sort of building Carter as a startup?
I certainly think it made us consider more about how sort of our focus areas around how data is used, how do you trust it, how do you understand it, and how do you scale knowledge about it. I think the fact that we kind of lived that problem for quite a number of years was really helpful in trying to understand how would we solve this with software. I think it's hard to solve that problem if you were to come in from like an adjacent field or not to have any sort of data experience. But I think what ultimately gave us a lot of insight was the fact that the failure rate was so high. And so that kind of helped us understand that there is a genuine problem with the fact that we spend a lot of time building, top quality data products, but the end result is that they largely don't get used. Seeing that in not just say where we previously worked, but in a lot of the customers we work with, sort of tells us that there's still a lot to be done. There's a lot of work that we still need to do to make data valuable in an organization. Despite the fact that we do have a lot of investment going into data at the moment, I don't necessarily see the value equating to the money that we spend on it.
I was going to go Ingrid, sorry.
I was saying just great insights. And it seems like from the comments in YouTube that a lot of people can relate to the problems that you are trying to solve. So very useful talk.
Yeah, I guess another question from me, Dean, is, like we've had some brief discussions about data mesh being sort of for like larger organizations and the like. And, oftentimes you hear about sort of data lineage and metadata tools and things like that being kind of similar, for organizations that have got lots of different data stores, and you actually need to go out and find things, because it's always a mess trying to find things in really large organizations, or I find at least. Is there a need for this sort of a tool in a startup, and what sort of size or sort of sets of challenges do you see kind of provides the impetus to looking at a tool like this?
I think it really comes down to sort of when does the scaling problem happen in data in an organization. I think if you have, say, one data analyst that is knows everything about all the data, then there really isn't a scaling problem, even if you have 2 or 3. The scaling problem really becomes sort of evident when you have, say, 10 or more people working in data. And that's when you start to have sort of tribal knowledge happening. You have these silos that are starting to occur where people can not easily understand or find the right data to use. And so you start to have these problems occurring. I think the thing with that I think about when it comes to lineage is that lineage is it's kind of, in my view, a nice to have in a way. And that's maybe a little bit controversial to say, in that when you need lineage is in very specific situations. It might be around sort of solving a pipeline problem, or you're trying to diagnose where this bad quality data comes from. I think where we haven't really stretched lineage towards, though, is how do you use lineage for the end user? They're not necessarily going to be the ones that are going to say, okay, I'm going to trace this problem all the way back. What they want to know, for example, is that, is the lineage actually supporting the fact that I can trust this data? And that's not necessarily something that you want to traverse, hundreds of nodes in a graph to figure out. It's really the end result to say, okay, this is something that I can use. This is something that I can trust. And so I think that's where we've got to bridge the gap between, say, the value that we can get from lineage into a product that actually comes from what is the output from good quality lineage.
Yeah, really, really interesting, because, I guess like data lineage, if you're sort of from an analytics background, I guess you're kind of looking for, okay, so this table that I'm looking at now that's feeding this dashboard that I'm sort of clicking the buttons on, does it come from this source or that source, and is that source and oftentimes, us data engineers have very convoluted ways of getting to that end result. So those DAGs, those directed acyclic graphs, or those lineage graphs, they can have multiple nodes, and it's a whole mess of spaghetti it can be. And I guess makes a lot of sense, rather than sort of, especially an end business user, that maybe this is their first kind of view of looking under the covers of a full data pipeline and stuff like that. Maybe just having a trust metric as opposed to all of this overload of information perhaps is a nicer way. So some really, really fascinating insights from you. I think, Ingrid, did you want to ask this question from Supra?
I think that we have a question that challenge you face in discovery phase, and what helps you most to get over that discovery phase. I mean, I want to understand your approach. That's a question for Sufrafa.
I'm going to assume this is about sort of the data discovery challenge, more than say how we sort of do discovery as a startup. But I think that the challenge with data discovery is, if you think about sort of the traditional information architecture in, say, a data catalog, the idea is that you go to search things. And I think that what we have found is that search is a little bit of a tricky problem when it comes to metadata. And the challenge there is because metadata is rarely rich. People are not necessarily putting descriptions, tags, all those sort of things, even in things like ETL, pipelines, code, etc. And I think the challenge with search is that unless metadata is rich, search is actually very difficult to get right.
it's very hard to search for something and expect, the top 5 results to be exactly what you're looking for if you're not necessarily able to search for rich context. And so the way we sort of think about the data discovery problem is, rather than lean on search as the primary mechanism to discover data, what if we could build a personalization engine around data based on what people use? So if we can sort of understand, for example, this data scientist is commonly using this data, as more data gets produced or new assets or new products get built that are similar, belong to the same domain, how can we actually push that as a recommendation to that data scientist? And so we sort of see discovery as, rather than sort of being more of a pull-based approach, which is sort of search, to being more of a push-based approach, which is more about sort of feed. So that's kind of the way we think about it. But the other thing with data discovery is that if you build a feedback loop that encourages people to crowdsource and put their sort of context into the product, into the metadata, then you can actually enrich that metadata so that it's actually more meaningful in search. And so there's a couple of elements there that I think if we take that practice to the full extent, we can actually build a really amazing data discovery experience for every data worker in an ecosystem.
Yeah, awesome. Juliana just chimed in. She said, such a great talk about a topic that often gets missed. Yeah, I mean, I guess it's similar for you, Ingrid. If I had $1 for every time someone asked me, can I trust this data? And where does this data come from? What database? Are you sure
Data
it's
quality,
accurate?
monitoring, testing, all those things. It's not just, as Juliana mentioned, it's not just that often get missed, that sometimes get deprioritized in function of, create business value. But if we prioritize these areas, and Dean, I don't know if you agree with me, but if we prioritize these areas, we actually can offer better business value at the end.
Yeah, no, it's 100%. I think the challenge with not paying attention to this, because I know as data engineers as a community, we're often spending time so busy because we're told to do things. And usually once we've done it, we kind of throw it over the fence and then we assume that it's good from there. I think the challenge is that product mindset though is you need to start thinking about the things that you're building as things that actually may last a long time. And so the more that we are able to sort of track metrics, understand who our users are, get feedback from them, the more that we can actually build products that last a long time, as opposed to things that sort of go to die in the dark. And I think the challenge that we typically see in in our customers is that they don't necessarily appreciate it, and I think that is a shame, because it's such a waste of opportunity and value that data engineers are spending their time on.
Even on the topic of even just tracking who's actually looking at what tables, usage metrics, it's amazing. I'm sure your tool must show up quite a lot of times that, a fair amount of tables within a warehouse or something like that are just not being used. They're not being viewed by end users. And so, if that takes you weeks and weeks and weeks to build out those tables, is it really worth it?
Correct. Or the opposite, like if sometimes now that it's not being used, is that probably you find that people is using it in a very complicated way, and as a data engineer you can come in and say, okay, you can simplify the process, and that's how you add value.
Yeah, I probably shouldn't say like what the numbers that we see are, but I would say they're in sort of single digit is usually quite common once you sort of have a look at, and when I say single digit, I'm talking about say data warehouses or data platforms or data lakes that are enterprise scale. So we're talking, millions of tables, files, etc. Tens of millions of columns, and when you start to actually look at what's being used, it's actually a fraction. And I think that that's actually really important, because understanding that helps with a whole other range of problems, whether it's around data literacy, data governance, data access. You don't have to spend all your focus assuming that you have to control everything.
it's actually a small footprint that you actually are generating value for over time. And I think that's kind of the thing that we don't always appreciate is the temporal nature of data. What's valuable now is not necessarily going to be valuable in the future. And yet we still may, for example, in 12 months' time, still be spending lots of money computing data or processing data that actually has no value. And so those are the things that, I think as data engineers, we do need to start considering, as opposed to just, spending all of our time just building the product.
Wise words. We're out of time, Dean. Really great chatting with you, and looking forward to sort of some of the discussion that is generated off your talk throughout the conference. Thanks once again.
Thank you, Dean.
Everyone.
So, Peter, I think that our next speaker is going to be Harmeet Sokhi. Harmeet is one of our co-hosts in the Data Engineering Melbourne Meetup, correct?
Yeah.
She's based in Melbourne, Australia, and she's going to be joining us today with a very interesting topic, shift left testing, building reliable data pipelines. She's a lead data consultant at ThoughtWorks and very passionate about data, so it's going to be a very interesting talk.
Looking forward to it. All right, without further ado, let's get underway.
Let's go.
Hello everyone, I'm Harmeet. Today we'll talk about building reliable data pipelines. And this first we'll discuss what is a data pipeline, then we'll talk about why do we need reliable data pipelines, and then we'll dig into what, why and how of shift left testing, and then finally conclude with a summary. So when we think about data pipelines have source data. We transform data into a target format that can be used to take some key decisions. It's as simple as that. But we all know that it's never that simple. As the pipelines grow, they have tendency to become super complex because they consume data from each other to get better insights, which is fine. But because of this complexity, we have observed that data teams start spending a lot of time in fixing data issues rather than adding value. And because of a lot of quality issues, business start losing trust in data, and that results in gradually low adoption of data-driven decision making in the organization. And there's a term for that. This is called data downtime. Barmoses have given a good definition to it. She says that the periods of time when your data is partial, erroneous, missing, or otherwise inaccurate is called data downtime. And does it matter? Yes, of course it matters, because bad data is bad for your business. As per one of the researches, has been found that organizations can lose approximately around 10 to 14 million US dollars, and it can cost them around 30% of their revenues. And it's estimated to cost the US more than $3 trillion per year. So what we can do? Definitely we have to fix the quality by testing and validating, and validating and testing early. And this is what is called as shifting left the quality. Why are we saying that the shift left works? These are some of the stats from the world of software engineering. And as per this, if we find a defect early in the development life cycle, it can cost us 100 times less as compared to a defect which we find in production. So it's clearly evident that shifting left work. But before we shift left in the data engineering world, we have to clear some of the basics. So when we say data pipeline, we know that data flows from source to target. But data pipeline, apart from data, also has some code, and code flows from lower environments to higher environments, and this is CI/CD pipeline. So consider these two pipelines as orthogonal pipelines. So there's data which flows in data pipeline, and code flows from the CI/CD pipeline. And when we are talking about testing or validation, we have to think about both these pipelines, testing early in both these pipelines. So those of you who come from a software engineering world might have seen this testing pyramid many times. So just like a regular pyramid tends to be the most stable structure in real life, the testing pyramid also tends to be the most stable testing strategy. So normally the convention is that you can have 70% unit test, 20% integration test, and 10% end-to-end test. The exact mix will be different for each of the team, but in general, it should retain the pyramid shape. Now, the unit tests are cheaper and have faster feedback. So that makes it more effective, and that's why it's suggested to have more coverage in the unit test. So similar to a software engineering application, we should test the data engineering application as well and map our efforts to the testing pyramid, and automation is the key. So let's take an example here. Let's assume that we have to write a pipeline or a job which does some sort of flight analysis to generate some great insights around flight delays. Now, as a data engineer, when I start writing that application, I'll start with smaller function. Let's assume that I have to first write a small function which will just give me that the output that how many times a flight has been delayed. So there's a function, small function, which says find the late flight. It takes a data frame. And if you've not used data frame before, consider this as a table. It takes a table as an input, which has just flight ID and the minutes by which it has been delayed. And as an output, it generates flight ID and the number of times, the count when the flight has been delayed. So how will I write test for this? So first, what will I do is create some mock data. I'll say create a mock data as a list, and I'll say take these inputs and also create mock data output. Now in this example, if you see this is an ID and this is the minute. So I've created that mock input, and similarly the mock output should be, that's what I expect, would be ID, and 2 times this 104 has been delayed. 107 has been delayed 1 time, simple count. So then what I'll do is convert this mock data into a data frame structure, which my function is expecting, any format that your function is expecting. And then once that is ready, now I call that function and it'll return the result. And then what I'll do is I'll simply assert whether the result that the function has returned and what I was expecting is true or not. So that's a simple way to test locally by creating some mock data. So in unit test, we normally do function level test where we kind of test transformations and we test small parts of the data product, and we normally pass 1 row or message, but we do not test the whole job or a driver. But then the next level of testing is component test. In the component test, what we do is we do a job level test and try to test things like does my job call the read correctly? Is my code properly inferring the schema? Are my reruns creating the same output every time? So we try to test the whole job in the component test. So again, let's take an example. For example, this my flight analysis, the whole job is actually reading data from some AWS S3 folder and writing data to some S3 folder. How can I test that locally? So what I'll do is when I want to write the test, so this is my test. Now what I have to do is first create an input file that my job is expecting. So I will create a test file, and this is actually stored locally. I'll create a data frame out of it, and then I'll create a bucket locally in my local environment. I'll write that input file in that S3 bucket. So my input is ready, not in the AWS actually, but the mocked AWS S3 bucket. Then when my function would be called, it would be expecting that there is an output bucket where it should be able to write. So I'll create an output bucket again locally. So that's a mock output bucket. And then what I'll do is just call my program. When my program is called, my job is called, it will read from this input path, which is here, and then write to the output path if that output path has been created. Now I have to verify whether the the output which has been created is as per my expectation or not. So what I'll do is actually go to that output bucket which I had created, assuming that when I call this program, it should have written the output file there. So I'll read that, create a data frame, and we'll check the expected output is equal to the output file. So here I'm not actually testing the smaller functions, but testing the whole end-to-end job, whether it is able to infer the schema, check whether the whole read is working or not. When we were showing this we were doing this component testing, I spoke about local environment. So there are a lot of containers or simulators available which you can use to mock the environments that you have been using. This is again one of the examples. So there's a local stack which is available through which you can mock the AWS environment, and for Spark you can use this particular image. So try to find the images or Docker containers or simulated cluster through which you can run your test locally. So if we look holistically, we start with the developer machine. In the developer machine, we should write unit test. And in that unit test, we are not actually mocking the files. We are just mocking row level or message level. Then we write component test in the developer machine. And then we use simulated cluster, and you try to do test-driven development. Now, when this is done, commit it, and the same thing, the same test should also run in your CI/CD pipeline, because you don't want it to be limited to your developer machine. It should become gradually sort of your regression test. Now, let's move further. Once your data goes to the pre-prod environment, there are two types of tests which are important. One is your flow test. In the flow test, you actually test a data product in its entirety, including its orchestration or choreography. For batch processing, you can use your workflow tools and cluster to execute the entire workflow. And for streaming, you can simulate a producer to generate events. And in lower pre-prod environments, this can run with mock data and can be scaled in with a volume that's higher than what we used locally and in the CI/CD pipeline. And in the later ones, you can always use prod-like data. The other type of testing is exploratory testing, which is actually used to catch quality issues that are not yet automated. And this can also include some sort of cross-functional concerns, like making sure no sensitive data is logged into the pipelines. Let's further move ahead. Now we are in production. Now think about the left side of production. In the left side of the production data pipeline, we should do data quality checks. Now these are checks plugged into data pipelines to be run at runtime so that we do not run blind in production. They normally look like a field should only contain certain values, such as within a specified range. One field is less than other field or more than other field, or should be unique. So any quality expectations from the consumers or the domain owners are qualified or are codified in your data quality test. And it's better to test early before it reaches to the consumer and business finds out those issues and gradually loses trust. And the other type of test is anomaly detection sort of test. So it's gradually you can strengthen your pipelines by these. The anomaly detection type of test are useful to see any issues, keeping historical context in mind, some sort of distribution you were expecting, you've observed earlier, which should be pursued later as well. But one important point to note is that these quality tests and anomaly detection can also be run in pre-prod environments where you have a sort of prod-like data so that we can get earlier feedback. It's not just limited to the production environment. Now, here is an example of data quality checks. There are various tools available, but Great Expectation is one of the popular tools we use these days. So here in this test, we are checking whether a column is particularly existing or not. We are saying that the max value of like this field arrival delay, it's between 1500 to 1600. The other thing we are checking is the 95% of the columns are not null. So sometimes when you're doing certain analysis, it's fine that some of the columns are null, but you want to maintain a certain percentages. There are other type of tests like aggregation, frequency distribution, mean, standard deviation, and correlation between the column, which based on your data, you can also test. So when we talk about data quality test, you can always refer to this grid. Now, if you remember in the beginning, we spoke about the testing pyramid. So if you see this axis, this is your code testing pyramid. And if you see this x-axis, this is our data testing pyramid. Now, in this data testing pyramid, we have point, sample, and global test, which is point test are more around where you reason about specific cases like, invalid values and all those things. In sample test, you basically quantify certainty, risk, or sensitivity with a sample. A model does not discriminate based on gender. And when we talk about global test, we basically talk about evaluating certain parameters on the whole data set. For example, a data pipeline produces the same count of output as inputs, or maybe moving averages within the historical bounds or not. So use this practical data test grid to make sure that your data quality coverage is fully there or not. So apart from this testing, it's important to actually invest and understand in data contracts as well. So in the data pipeline, we produce data products. But if we think about the left side of it, we have a certain source. And if there's a certain source, there are data owners. So it's important to identify the data owners and have a data contract with them. In that contract, you should have contact information, understand their responsibility, make them responsible for the quality of the source, and in the contract, capture the metadata information like schema and the format of data, and use it to validate the contract. So as the data comes into the pipeline, and if it is not as per the contract, alert them, use the contact information in the contract to alert them so that they can fix in the shared responsibility model, before the low quality data reaches the consumer. So it's important to capture the contract, but also invest in logging, monitoring, and alerting so that it can be they can be automatically alerted, and that it can be fixed before anything goes wrong. Now, we have spoken about a lot of things, but if you want to create an image, I would say that you can think of it as a ladder of reliability, where you have automated tests in your local and CI/CD environment. You have flow tests, exploratory analysis, anomaly detection, quality test, and contract, along with data contracts, and all this supported by logging, monitoring, and alerting. And this will help you have more reliable data pipelines by testing and validating early, that is shifting left. Now, to conclude, I would say that there is no silver bullet and software engineering principles are still valid. We have to test and validate early, that is shifting left, and automation is our savior. We have to move away from untested, unstable, and undocumented, and shared responsibility model is critical for the success of data pipelines. And observability is our path to faster recovery. Thank you.
Hi, Amit. How are you?
Hi, Peter.
Hello.
I'm good. Hi, Ingrid. How are you?
Good, and you?
Good.
Well, fantastic talk. Shift left on testing. That really, really insightful stuff. I think a lot to learn from that in terms of, I guess, bringing software engineering best practices into the realm of data. I think you touched on it in your talk, but there are a couple of slight differences between how you do sort of testing in software engineering, sort of delivering software, versus some of the tests that you would do in data. I think you were mentioning point tests and things like that. What are the differences that you see quite commonly in the range of tests that should be carried out in your data pipelines?
Yeah, I think the key here is definitely, as I mentioned, software engineering principles are still valid and we have to follow that. But what makes data is the factor in the data pipelines, which makes it a bit different, adds a extra layer of uncertainty in the software engineering. So yes, all those tests that we can do in the, when we look at the data, it's important to check like column values, null values, and all those distribution. But I think overall, adding to what I mentioned in the presentation, I think it's important to actually give a lot of value to exploratory testing as well, because there's a lot of unknown. So that's where we should invest time in the exploratory testing and find those unknowns and see, and when we figure out those unknowns, add them into the data pipelines. And when I say the data pipelines, is important to understand the horizontal and the vertical side of the pipeline. So when I say like horizontal code data pipelines is the horizontal part, and in the horizontal side, make sure we are checking the quality at the left side of the pipeline and not moving towards the right, because I've seen that like when we talk about the BI tools and all those things, so we don't want to add a mess there. So it's important if the quality is checked on the left side of the pipeline when the data gets ingested and your pipeline start running. So that's the key. So I think 2 cents, give value to exploratory testing and check the quality on the left side. And I think the other thing would be I think shared responsibility model is a key here, because normally what happens is we don't the data platform owners would not know about the data. It would be mostly the product owners or the people who understand the data would know more about those. So it's important to make them have that shared responsibility model and see how they can be included in those quality checks.
Anthony is asking, great talk with great code, library to use. Any good books, websites you recommend to learn more about data pipeline testing?
Yeah, I think so. I mean, especially, I mean, from the website perspective, I think there is. I mean, I don't know about the specific website if there's any, but I think there are some good articles which I would recommend, which especially about our colleague Dave Coles has written, especially on the data grid side and how we can also include synthetic data testing. So those are something which I would say, and plus I think the key here is about making sure. There are some models. So apart from the testing pyramid, there is a model which is called Swiss cheese testing model. I think that is also key to the data testing, just to make sure that we're covering every part of it. And I think from the data perspective, it's important to understand the distribution of data and think about what goes wrong. And maybe I'll look at my bookmarks and see if I can find some good websites which I may have marked especially for testing, and I'll share it across.
Thanks so much for that, Harmeet. Claudia Silva's asked, could you please provide some examples about exploratory testing? I guess the question that I had, I'm guessing you've got, a typical, CI/CD pipeline where you've got an environment, end-to-end sort of, where you sort of, you've got your data pipeline and perhaps a data warehouse in development, and then UAT in production, or QA or whatever it's called in the particular environment. How are you doing the exploratory data analysis? Are you doing it on source, or are you landing it in your sort of dev data warehouse and then doing the exploratory analytics and then feeding it back? And I guess some examples on that side of things.
Yeah, I think it depends on your data product as well. So what kind of data product you're creating. So it lies on the. So there are two sets of people who would be responsible. Definitely, we want to make some sort of basic checks at the owner side, but then data product owners are also responsible for that sort of testing. So when you start building a data product, see what type of data sets you would need, and that's where the knowledge, your assumptions would come into picture. So the data product owners would have certain assumptions about the data. So that's where you need to bring in those data sets. I mean, simple way would be just use Jupyter notebooks, and it's not the pipeline. That's where basically your it's a first level of setup where you try to figure out what unknowns are there in the data sets, or what assumptions are not right, or whether your assumptions are right or not. Take Jupyter notebook, just have take samples of your data, see the distribution, and see whether your assumptions are right or not. So that is like a plain simple way of doing some sort of exploratory analysis. And adding to this is not a one-time process. I think this should be like a part of your whole life cycle of the product, because definitely you cannot, in day one, you cannot build 100% quality into the system. So as you keep going, as you enhancing the product, you should keep doing more. You'll keep figuring out new things. But the thing is, as you find the bug, the first thing should be add the test in, and then update your code, or change your code according to this.
Yeah, it's fascinating. I think we had Mercedes in her talk, talk about sort of having feedback loops to, sort of auto detect those bugs, and then, sort of add. I mean, that was in a machine learning model use case. So I guess add that sort of particular data point to the model building process. But I guess in a similar way, you can sort of have that auto detection and include it in your battery of tests or whatever to ensure the robustness of your data pipeline. So any questions as well, Ingrid?
No, I really enjoy this. I think it's very important, and I think that we should start adopting more and more in the community. Having that early testing, it will definitely improve quality of what we deliver.
Absolutely, it's like eating your vegetables, isn't it? It's got lots
Yeah.
of long-term benefits and stuff like that. So
Yeah, and it has been an evolution because I think that when data engineering started, we thought that the quality was a problem on the right, like at the end of the pipeline, and I think Harmeet had explained very well why we should make it a pipeline behavior. Yeah.
Yeah, I think quality is everyone's responsibility, not just, towards the right to a QA or
Correct.
someone who's, has that responsibility. So yeah, we should. And the other thing which I've seen across like my career is that normally because of time pressure of the products, people try to not do testing just to, ship product, but then they have to like pay towards, in later about
The
because
consumer has to worry about the details, yeah,
Yes.
which is not ideal, yeah.
Yep, some fascinating insights, Hamid. Really enjoyed the presentation and chatting with you. Yeah,
Bye-bye.
thanks once again.
Thank you very
Thanks.
much, Harmeet. Thank
Thanks,
you.
my pleasure. Thank you.
How good has been today, Peter?
It has been wonderful. We've got up next Chris Benson from Versor. He's brave enough to present live. No pressure,
cool.
Chris.
Chris is joining us from Melbourne, and today he's presenting Beginner's Guide to Azure MLOps.
Yeah, thank you very much, everyone. Presenting live is actually easier than trying to make a video, to be honest. At least I think so. Am I the only one presenting live?
There's been a couple of others. It is quite a time-consuming process, pre-recording, funnily enough. But for whatever reason, I always find myself, I inject probably double the amount of ums and ahs if I'm trying to record myself. And so I'm just perennially editing them out. So, well, both myself and Ingrid are super excited about your talk. We'll share your slides and take it away, Chris.
Great. So you can see my slides now. That's all good.
All good. Yep. Give it a whirl.
Thank you.
Thank you.
Excellent. So thank you very much for that introduction. Really what this is about is an introduction to Azure MLOps. I will touch on machine learning concepts, but essentially it kind of assumes that you have some machine learning background already, and you understand the very basics of machine learning and data science processes. So let's just jump straight into it. So first thing we're going to do is we're going to jump in and talk about the machine learning process. Once we've gone through that, a lot of you might have seen that process previously. We'll look at specifically then jumping into Azure and what does Azure machine learning provide us around what are the features that are there, what is the service that Azure machine learning provides, because although you can use some of the drag and drop features in Azure machine learning features, the service provides an entire development environment for you to actually code against, so a whole chunk of SDKs, etc., that you can use. Very importantly, an understanding of pipelines and experiments and how they work within the machine learning lifecycle. And then I'll jump in and just show you a little around Azure ML and some of the concepts in Azure ML itself. So let's jump into the first one and talk about this. So really, what is the machine learning process? So just like there's a process to go about developing software, and just as previously you heard from Hamid around developing test cases, there's obviously a process around the development of a machine learning model. So one of the first things that we need to do is we need to have a really good understanding of the business. A lot of times people think that machine learning is the silver bullet, that you just throw the data at it and you chuck it into some machine learning machine somewhere and it's going to spit out all the right answers for you. Actually, you got to start with a really good understanding of what you're trying to achieve, and asking the right questions. And it's a bit like a that's why they call it data science. It's a bit like a science experiment, right? So you have a hypothesis, you go and you create an experiment, you review the results of the experiment, and finally you have a conclusion around it. And very similar to the machine learning process that we're talking about here. So we need to make sure that we define the problem correctly. Once we've defined the problem, you've got to go and have a look and see if you can answer that problem through some of the data that you may have. It's no use asking a question about something where you don't have data to answer that question, right? So you've got to go in, extract the relevant data, explore that data, profile that data, and in some cases clean the data as well. Once you've collected your data and you've built up some statistics around your data, you go into what they call feature engineering. Now, feature engineering is an important part of the machine learning process, as it uses those features to actually as input into the model and into the algorithm to determine the predictions that are going to come out of it in the end. Because what is machine learning? It uses existing data to actually learn from the data and then spit out the answers, right? So through feature engineering and feature selection, very important, you combining data together there, you're removing certain features that aren't in there. There's a whole science just around feature selection and feature engineering, around correlation and causation. And we've probably all heard the nappy and beer story before. If you haven't, hit me up at some point in time, I'll tell you about the nappy and beer story. Although I hear it's a fallacy. It's just a legend. It didn't really happen. So once you've got your features engineered, you're then going into where you go to your model selection, which is around selecting the right algorithm that you want to train the model on. What you do is you take the data that you've collected, you've got your features in that data, you split the data out into 70% for training, 30% for testing, and you go and you train your model, you test your model. Hyperparameter tuning is around tuning the underlying model itself. You may have some cross-validation there around the way that you test the data, etc. I'm not going to go into those details at the moment, but once you've done a number of tuning or you've done tuning around your model, you're ready to then finally select the model. But what we've found in a lot of cases is that a lot of businesses out there are getting to that point. They're getting to the point where they've gone and they've grabbed themselves a model, they've tuned the model, they've got a great model, but now they don't know how to get that model into production. And just like any piece of code or any app that goes into production, you have to move a model into production in very much the same way. Once you begin moving a model into production, there's a number of ways that you can have the predictions come out of that model. Batch inference is exactly that. You run it on a daily basis, it spits out a whole chunk of predictions, and you can go and go through those predictions. Real time is similar to your Amazon.com, going and buying a book, and there's a recommendation engine behind that. And as you're selecting that, there's some APIs in the background going, hey, you like that book, you're going to like this book as well. So that's real-time inference. And then we've got edge deployments, which is also real-time, but it's much closer to the edge. So if you think about, a car that you're driving, a self-driving car, you don't want it to have to go to the cloud every time that it sees a person in front of the car to say, hey, by the way, can you tell me whether this is a person in front of the car and I should brake or not? You want that at the edge. You want that right where the car is. So you want it as fast as possible. So that's your edge deployment. You get those in a lot of cases in mining companies and manufacturing and so on, where there's a lot of telematics coming through and SCADA type data. And then finally, once you've got your model into production, you need to operate and monitor your model. What we're going to be talking about in this particular series is how to take some of the things that are on the left-hand side of that deployment and understand how those fit into Azure ML, and then where the other pieces fit into both Azure ML, the deployment and the operate and monitor fit into Azure ML and into the DevOps lifecycle. So just jumping onto Azure machine learning features, there's some of you may have played with some of the cognitive services out there. That's the domain-specific pre-trained models around vision and speech and language and search. There's a number of pre-trained and domain-specific models that you can use, which reduces your time to market and can really help you. And things like if you wanted to do PDF and Word searches, document searches, etc., all come into there. Language is another one, being able to translate different languages and so on. Familiar data science tools. If you're familiar with the with PyCharm, it's another environment you can use within Azure Machine Learning. Certainly the Jupyter Notebooks, if you've developed in Jupyter Notebooks before. If you're on the Microsoft environment, you've probably coded in Visual Studio Code, and the typical command line terminal environment that you could use as well. There's a number of popular frameworks. These are just mentioning a few, by the way. There are a whole chunk more. So PyTorch, TensorFlow, scikit-learn, scikit-learn. Let's get that wrong. I say Sky. Scikit-learn and the Onyx framework as well. And then, in terms of being able to give you the right compute to both train your model and to give you inference, there's Azure Databricks for those very, very large data sets that you may be looking at. It can connect into Databricks, and you may have heard of ML Flow, so that's on the Databricks side. So Azure Machine Learning is really doing a large chunk of what ML Flow can do as well. You've got the Azure Machine Learning compute, and you've got a number of pre-configured machine learning VMs, and I'll talk a little bit about that when we get into environments later. And finally, they all run on powerful hardware, CPUs, GPUs, and FPGA is that edge compute that I was talking about earlier. So jumping into Azure Machine Learning Service, it's a set of cloud services plus a Python SDK. So what it does is the Azure Machine Learning is an SDK on its own. You can go through and instead of having to use, as I mentioned, a whole manual method of registering models, registering data sets, creating pipelines, creating runs, etc., it can all be done with code. Everything can be created with code. And so the ultimate goal with ML Ops is that you have a zero-touch environment when you're deploying to your staging or to your production environment. That includes deploying your infrastructure as code. So you want to sit down the entire infrastructure that you're going to be using, that's including all the compute clusters, that's including any stores that you're going to be using, etc., as well as all of the machine learning pieces that you want out of that. So things around preparing your data, building your models, registering your models, managing your models, the monitoring of your models, etc. The whole goal is to have a zero-touch environment when you get into production so that everything is deployed as code. What the machine learning service allows you to do is that. It gives you that ability to actually code towards a zero-touch environment in production. So just jumping in and as I mentioned, quite importantly around machine learning pipelines, what you can do is you can take a number of pipelines in the Azure machine learning environment and break up specific pieces that you're wanting to do into these pipelines. So you can have a pipeline to prepare data, you can have a pipeline to build and train models, and you can have a pipeline to deploy and predict. Why do we have this? Well, I've been through a number of places where they have what they call multi-model environments, where they're not building one model, they're building 250 or 500 different models because of the way that their data is structured and what they're trying to do out of their data. Now, doesn't matter how much compute that you throw at that, if you're not got some parallelism somewhere in there, you're going to run into some problems around serialization and all sorts of things. We've seen where you use pipelines correctly within Azure machine learning, builds go down or training goes down from what was running in this particular instance from 6 hours to 20 minutes to build 250 models. So using pipelines and using parallel steps inside of your pipelines, you can certainly make use of those much larger clusters to run your training environment. What is experimentation? So this is what I mentioned around science and data science a little bit earlier. So really it's around every time that you run a model and you do a training on that model, you want to capture what was the data set, what were the features that we used, what was the hyperparameters that we used during your normal machine learning or your deep neural networks. What was the compute cluster that it ran on? How long did it take to run, etc. And over time, you want to capture every single time there's a run. Why do you want to do that? Because just like I mentioned with that science, experimentation, you're refining the model every run that it goes through to make sure that you get the best predictability or whatever parameter you're going to be using to determine the best model. But to get the best out of the models that you want. So whether that's going back and tuning your features, or whether it's going back and doing hyperparameterization, or it's using things like AutoML, you want to make sure that every time you run it, you can come back and have a look through your experiments to look at exactly which model gave you the best performance and what was the parameters that we used, what was the data that was used for that. So that later on, when you come to building the model again, you go back because there's something called data drift. I'm not going to go into a lot around data drift right now, but especially when your model's in production, data moves away from what the data was originally trained on, and you have to go back and have a look at what that data is and retrain the model, etc. And redeploy it. So experimentation's a very important part of that, and you're wanting to capture your experimentation runs. So, just a touch on model management in itself. So once you've selected the right model, you want to be able to monitor that model. You want to be able to register that model. Everything that you would do, just like you would do with a standard enterprise application. So you roll out, SAP version 1, 2, 3. You want to monitor that version. You want to make sure that that's the right version, and you want to continually deploy updates to it. The same thing happens with your model, right? So once a model's deployed, you can't just leave the model and then walk away. You have to monitor the performance of that model. You have to monitor data drift. You might come back, retrain the model, re-register a new version of that model, and then monitor all over again. So the cycle just continues, just like you would do for any other application in your environment. And that's the part that we found that a lot of people seem to struggle with within organizations, is getting that model from, what was an experiment and they've now got the greatest model, but how do they actually get that into a production environment? How do they actually monitor it and then monitor the data drift, etc. with that? If we bring all of this together in one slide, what MLOps is it's taking that experimentation part and building and training and building the model, and it's adding on DevOps as well. So standard DevOps, most of you have probably seen this process before, this great infinity sign. This is now infinity on infinity. I don't know if you can have that. I'll coin the term. But essentially, you got your development environment where you build, create your product, package it up, you release it into your operational environment where it gets monitored and configured and managed over time. But it comes back, you got to continually update and build. While in this case, you've got this extra piece of machine learning process that you've got to do in this case as well, which is around, if we have a look at this build and train models, parameterization, experimentation, and pipelines, taking all of that into the train and testing part of it. Once you've done all of that and you've got your best model, you want to then go through, deploy your model into the production. That's around registration of the model. You want to monitor the model. You want to also understand all of the components that the model relied on. You might be using, a number of different libraries, very special packages, etc., that were coupled with your model. You want to make sure that those are all deployed together as well. So, model 1 may have used version 10.1 of a specific library. Model 2 may be using 10.2 and cannot use 10.1. So you've got to manage the dependencies and all of those things that go with the model as well when you register your model. That's what that build image part is around over there, especially if you're using things like Kubernetes and so on that you want to deploy to for inference. Build your image, deploy and monitor the model, and then finally come back, redevelop, retrain, etc. On that. What I'm going to do now is I'm actually going to go into Azure ML Ops and just give you a bit of an understanding of what that looks like. So right here, I've gone and created inside my Azure portal, I've pre-created a Azure ML demo workspace, machine learning workspace. It pre-configures some things for me, like storage, container registry, a key vault as well for managing secrets, and application insights is used for the monitoring part of things. So that's where it can monitor network statistics and so on in there. If I click on Launch Studio, what that does is it opens this environment for me. And essentially, this is where I can go and create my models. I can go and see my experiment runs. I can register my data sets, my pipelines. Everything that I was talking about in the slides is what we do in this Machine Learning Studio environment. We have our notebooks, which is just very similar to the Jupyter Notebook environment that I mentioned earlier. You can see it's got different things where you can, different cells that you can run independently. You can have Markdown in here and so on. You can attach to a compute and you can run it on a specific Python version as well. I have automated ML. If you've heard of automated ML, or if you haven't, if you haven't heard of automated ML, it's a process where instead of training the model on just one type of algorithm, regression algorithm, it trains it on a number of different regression algorithms. So I'll just open this particular one up here, click on models. And in this particular scenario, this is just one set of code that's gone and run against all these models And in the end, it says that the voting ensemble is the best model based on the Spearman correlation that I said choose the model on. So in this case, almost 95%. And we can also view an explanation around that model there. I have the designer. This is for people that want to start out in machine learning and just want to play around, etc. You very much a drag and drop environment. They give you a number of sample data sets, etc., that you can use to train the model, score the model, evaluate the model, etc. And it's really easy to use when you just starting out. If you also got some Python programming, well, then that's where you go back to the notebooks and you can see a whole bunch of Python being done in here. In terms of the assets, we've got, as I mentioned earlier, when you run your experiments, etc., you want to, I haven't registered in any data sets at this point, but you want to register some of your data sets for use. You have experiments, which I spoke about. I can go in and have a look at this. There's been 2 different runs on this one, run 1 and run 32 in this case. I don't know where it got run 32 from. I only ran it once or twice, 3 times. It also makes up its own names on the display name of the runs. I love it. Neat raisin, upbeat drop. I didn't put those in. If you run them, in fact, I'll just kick one off very quickly. Run all cells. It'll come back and it'll put an experiment run in under this tutorial, New York City tutorial, and you'll see one running in a moment, and it just makes up the name. Pipelines, as I mentioned earlier, it's part of the runs. You can split your pipe downs. There's multiple steps within your pipelines, as I mentioned earlier. Very, very important for parallelization. If you're going to register your models, this is your model list. You register, it gets a version number and all the bits and pieces. You can tag it with what packaged versions, etc. it needs to go with as well. Endpoints is a way for you to create a real-time endpoint within here on a specific compute cluster, which I'll speak about in a moment. And so you can just have an API endpoint there. Typically what we do in this case is you create a compute cluster with an API endpoint that you give to your developers. So there's somebody that's got an application out there, like the Amazon.com example. If you're a retailer and you're wanting to do, recommendations, etc. in there, this is where you can create those endpoints for your models inside of Azure ML. Compute, I can have single compute instances. I can have my own compute clusters that I can create in here. I can have inference clusters. That's actual runtime clusters for either real-time or batch inference. And I can attach compute as well. So I can go and create Kubernetes clusters and attach them here. I can attach Databricks clusters, etc. all from in here as well. Environments is something pretty new and is really around, okay, I want to create a particular compute node with a with ML flow. I want to do it with PyTorch or TensorFlow, etc. in there. I can use these different environments for that. Data stores is just registered data stores that I might want to use, so that only the people that my data scientists that get on here only use certain data sources that we've given them access to. For example, it may be a data source might be to your warehouse. Yeah. Basically, that's what I wanted to show you today. Get into Azure Machine Learning Studio. There is some GitHub stuff available as well. On GitHub, if you go in and you type in Azure ML Ops Accelerator, you'll see Vias has put together a great a guide that you can just use. There's also documentation. So you click on this link. There's a great set of documentation around it that we're still putting together. Just note it is in development, but we're still putting together some documentation on that. I know I'm a little bit over time because I had to do things live, right? So any questions? Anybody want to know anything?
So what? Awesome presentation, Chris. So what's the website you get to go to check this out? Is it Amazon.com or no? Azure. Bit of a joke.
Yeah, it's Google. It's AWS. No, it's it's Microsoft's Azure environment, and that's what this is. Look, there are definitely similar things in other environments, but I kind of like what Microsoft's trying to do, in terms of getting everything into one place for you to be able to manage it.
Yeah, really appreciate you taking us through the whole sort of machine learning stack on Azure. It's super valuable for the community to sort of we've got probably a mixed bag of where folks are doing data engineering and machine learning. We even saw in the earlier talks today, some people are doing it on-prem, because they're working with IoT and the like. So that's really cool. One of the questions we had, it was answered, but Eswara Prasad was asking, model productionization and inference, are they same or different?
So you can still have inference when you're doing it in a test environment or staging environment, right? So essentially, they're similar, but they're not exactly the same. Productionization means going into prod, right, and monitoring it in prod. How you go into prod and how you do the inference is up to you, but you can still have inference in test just for your test environment and staging environment. But quite often people will put the two together. So just be careful of that.
Yeah, that's make sure you label your endpoints appropriately with like dev and prod and stuff like that.
Exactly, that's 100% right.
Ingrid?
Yeah, no, I really enjoy. I'm curious about what kind of feedback have you got from the community, and who are your normal users of these data engineers, data scientists? Have you got any friction around it?
No, so it's a mixed bag actually. We in fact, in this Azure MLOps accelerator documentation area here, they talk about skills, roles, and responsibilities, and it's quite important to understand that because you've got not just data scientists, but you've got data engineers in there because a big part of getting the data and cleaning the data is part of the data engineers area, right? And you've got DevOps engineers in there, right? Because they need to understand how to deploy the infrastructure as code. What I didn't mention, I was showing you all of that stuff through the interface there, but it can all be deployed. That whole thing can be deployed as infrastructure as code. And in fact, there's an example there of where we've got examples of the environment set up in ARM templates to actually go out and deploy the actual Azure ML workspace with all the pieces that are needed plus the compute. And then there's another piece that we've got where we would be deploying the actual pipelines and experimentation and all of that sort of stuff in there using the SDK. So long-winded answer to your question, but yeah.
No, perfect. Thank you very much. Yeah, it has been good.
Yeah,
I hope everybody
really
enjoyed
good.
it. It was short. It's difficult to do these things in such a short time frame. I wish I could show you so much more, but hopefully it gets people onto it. It's a really nice play environment if you want to just learn about just ML, machine learning in general. It doesn't cost you a lot of money to get started in there, and then as you get better and so on, you can start doing more ops side of things, which is really the point of, getting your models into production. That's the hard part. It's not hard, it's just people don't really know where to and how to go about it normally.
Good point. Yeah. Thank you very much, Chris.
Yeah, just finally, Chris, Azure DevOps versus Azure Data Factory. Would you run MLOps in Azure Data Factory, or is it more of the realm of Azure DevOps? Is it?
Yeah, it's definitely the realm of DevOps. Data Factory is an extract and load tool. For data.
Yeah.
Not a transformation tool unless you put some additional things inside of Data Factory, like SSIS or the data flow. But essentially, it's just an extract and load tool, and it can do some orchestration. It's not unusual to find an ADF pipeline having to load some data into somewhere like your lake for your data scientists to use.
Thanks for the clarification on that one. Yeah, that's really, really good to know. So, I'm guessing you're on Slack after this, Chris, and you're free for a chat and all the rest. So, thank you once again, and now we're just going to wrap it up and preview day 2. So, thanks, Chris.
Excellent.
Appreciate it.
Thank you.
Chris.
Thank you very much, everyone.
Thank you. We had an amazing day, Peter.
Yeah, it was. It was like, learned so much. I'm like, gosh, I need to have a sleep now and prep for day 2.
And let's do all over it again tomorrow.
Yeah, another big day of learning. What have we got in store for us, Ingrid?
Well, tomorrow we had an amazing lineup in the morning. We have Bar Moses, we'll be talking about data mesh. Sarah Krasnick, talk about Great Expectations and Airflow. Maddy Ascari, Reliable Data Engineering, and Mike Robbins, Data Quality, the Key to Long-Term Happiness. That's our morning lineup tomorrow. So make sure, everybody, that you join us tomorrow at 10 a.m. for a great morning talk.
Sounds like a plan. Well, thanks everyone for joining us, and ciao for now.
Thank you, Peter, for having me.
Thanks so much, Ingrid. It's really been enjoyable. Bye.